Yes, ma'am. Good evening, Dr. K. Sudhir Reddy, sir, organizers and participants. Welcome to the third day of ATAL FDP. Welcome to one more session, sir. Dr. Sudhir Reddy, sir. Participants, yesterday with more interactive session and we got more knowledge and we bagged more knowledge from Sudhir Reddy sir session. And today also, I hope you can gain more knowledge. So, thank you, Sudhir Reddy, sir.
Yeah. Good evening to everybody. I think it's time to start the proceedings for the day 3, session 1, and I welcome all the participants to this third day faculty development program. So for first few couple of minutes, probably I can share what exactly that we have covered in the yesterday proceedings in session 4, and then I'll take you through the next set of my presentation. Right. So what was covered yesterday was we kickstarted the fundamentals of. Kickstarted the fundamentals of secure code, what is secure code, and how do we create secure code components for the code that we have developed for web applications or mobile applications or any sort of applications that are actually taking off. So subsequently, we have come across with the different aspects of principles of secure coding and understanding various challenges, issues associated with the regular code, and how do we convert that regular code into a kind of secure code. And of course, also we have discussed about various issues pertaining to the challenges and associated with reference to the architectural and platform related issues, and how do we mitigate the software engineering life cycle model with reference to secure coding development model, and other aspects that we have come across. Also, as part of examples and case studies, and a couple of examples were discussed, and the kind of string issues were discussed, and integer boundary issues were discussed, and of course issues which are corresponding to buffer management and also has been taken up. So now I think it's time for us to kickstart with the subsequent procedures for the day 3 for session 1. And as yesterday, I think today also we will have first 1 hour for the discussion, and in between I will show you certain coding snippets and demonstrations as part of our regular procedures. And then we'll give some time to understand the different code snippets. In between, there will be some questions, quizzes, wherein you can think of yourself and answer them through your chat windows. And then at the end of my presentation, probably today is a second session, no? So I think you would have some good number of questions from yesterday's and today's topics. So we'll devote about 20 minutes time for the Q&A sessions. So Q&A sessions. So this is how my session plan for the day. So let me share my presentation, and then we will go ahead with the proceedings of the presentation. So can you tell me that whether you can see my presentation?
Not yet, sir.
You can't see my presentation. You can see my screen, ma'am.
No, sir.
Yes. Now it's okay, sir. Now it's very
okay, sir.
So you can see my presentation view or full view.
Presenter view only, sir. Not the full view.
Can you adjust as a host? You can set the settings.
Actually, from your end only it can be adjusted, sir.
Now
Now it's okay, sir.
My end I cannot adjust. My end that is a presenter
If
view.
now
Okay.
it is okay, sir.
I was I was asking something else. Okay, all right. So you can hear me, right, ma'am?
yes, sir.
Yes, sir.
Yeah. So this was the last slide that we have discussed about integer overflow and the concepts of buffer overflow, wherein we have discussed about how do we protect our applications by enforcing certain coding components. So that's where we can get into protecting our systems, protecting our processes, and of course we can safeguard from the hackers and the other intruders. So right, so I just move on to my next example. So wherein I will be presenting two different examples. One is normal code, and other one is the code which is equipped with some security aspects. So the second example is something like buffer overflow concept. In general, what exactly the buffer is? Something like a buffer is a temporary memory, wherein it is part of your primary memory, which is random access memory, and whatever that you type in from the keyboard, or whatever that you process through your data to your particular system, then that particular amount of memory will be stored in the buffer. And then I think it is easy for any intruder or a hacker to hack, or could create a kind of vulnerability in your system. So if you look at this code, I just take an example of entering the passwords. So this is the most sought after example. Generally, what we do, we type username and followed by password for logging into our email systems or any other enterprise related systems or applications, or even banking system or whatever it may be. Generally, we type some password, and then generally, how do we accept the password as part of your hard coded thing is something like getters function. So getters is something like that reads specified number of characters, alphanumeric or numeric or alpha bits from a stream, and they store in a buffer. So so once this is done, for example, it automatically takes care of storing of the data and then processing of the data by the subsequent statements. So the subsequent there is a conditional statement where string comparison with reference to number of characters is what is comparing with some kind of backend application. So you are writing some code with whether it is equivalent to something like zero or matching with zero kind of thing. Then you are saying password is verified, and you are authenticating the user to get into the application. Now, this is another code. Probably you can understand. The another code is something like, instead of using getters function. So in the previous example, we just use getters. Here, fgetters is being used. So fgetters is something like, which is more alternative way than getters function, wherein security vulnerabilities, whatever security vulnerabilities that encounter through getters will be fixed by this fgetters. Because this manages, fgetters manages something like how many number of characters that your stream is having, and it is ensuring that those number of characters only will be taken care by your fgetters. Whereas getters will take n number of characters, where even empty spaces, blank spaces, and of course additional characters also that will be taken up as part of your getters function. So pardon me, I was actually reversed I think in the 2 minutes back my presentation. So getters is something like which takes every single character that whatever that you enter, even more number of characters also you enter, so it accepts, and the same thing will be, I mean, compared with your conditional statement, and it produces maybe erroneous result or something or the other, and it leads to a kind of vulnerability where intruder can check your password and I mean hack your password and do whatever the kind of malicious activities that he or she can do. But here in this f gets function kind of thing, whatever we do is something like we can quickly go through the procedure and understand how many characters that we are pushing in, flushing in, and the same number, I mean the count of characters, whatever that we pass. So here you are passing only 9 characters, so that indicates that the length of the string is only 9 characters. So I am making it strict process so that my standard input only takes 9 characters, and that is being processed within the logic that I am going to build as part of my program. So this is why very simple code change. This is not a great extraordinary, I mean, bringing artificial intelligence or machine learning technologies into it to make the code is, I mean, secure and all. No, absolutely. It's just a couple of versions of your functions, and each function is typically having their own, I mean, limitations and advantages, and whichever the advantageous one, then probably we can choose. So it is the wise decision of an end user or wise decision of a programmer to choose which function that he or she shall have to take. I think I can move on to my next slide. I'm slide number 19. So here I wanted to present something, again, the similar kind of thing, the buffer size. So there are two different versions of code. Again, I am presenting the first version. Initially, I will explain what is this all about and how is that this worked. The character I am reading an array of character. Array name is user pass, and it has the 5 characters of length. And then I'm just asking the user to enter the password. And then here again, I in the previous case I used gettys, and now because gettys has some kind of limitations, so I've changed myself to fgettys. So wherein exactly nine number of characters that I wanted to present and presenting. So if you look at here, your array size is something like 5. Your array size is something like 5, but you are taking 9 characters from fgettys. So now fgettys also is being producing a kind of I mean wrong notion of practice. Right. So you have created an array with 5 character size, and then you are passing some kind of argument to your reading function. With that argument, you are passing 9 characters string, where it will store, So there is no possibility of storing, only up to 1 to 5 characters that will be stored, and remaining 4 characters will be somewhere in the buffer. Again, this is a biggest challenge kind of alternative. Now, how do we fix such kind of things is what I'm going to now cover as part of this example. Look at the second version of the code, right? So I have changed my logic, slightly changed. It is not, again, I am saying it is not a great, I mean, what I mean to say, like great technological advancement is being introduced as part of my second code. You just look at the second code wherein this integer buffer size is equals to 9. So I'm actually declaring very easiest way, a kind of a constant value. It remains same during the execution of the program, and then I'm creating an array. This array is, again, I have changed my, I mean the way that I created array in the previous example. Now I have changed it. So char user pass of buffer size. So that means whatever the buffer size that I set in my first statement of the second code, the same thing will be taken up in the character array. So now user pass is an array which has a capacity to store 9 characters. And then here again, a similar code, I'm prompting the user to enter the password. Same function fgettys, because I have merits with this fgettys function. That is the reason I am incorporating. But earlier code, in this code, I have wrongly annotated this function fgetS with my ignorance or with my over enthusiasm. I put some a number called 9. But here there is no such problem, because since this 9 is being stored in a constant, which is a buffer size. So I'm reading that fgetS user pass buffer size standard input, so that whatever the 9 or 10 or 20 or 100, the same number is being taken up, and the same is being checked with your conditional statement, and then whether verifying whether the password that the user has entered is similar to the password that is a part of the system. And then it gives you some kind of authentication or verification code saying that your password is being verified. So, in a nutshell, what I wanted to cover as part of this slide, how do we present in a previous slide? If you look at getS versus fgetS, we have introduced two different, because both are suitably, interchangeably, exchangeably in one or the other program. So without any disturbance. Till now, we have done such kind of activities as part of our coding process. But now the next level of our coding, this is next level of coding, where we are incorporating, what is that called? We are trying to incorporating something called advancement of your code, or secure code, or whatever that you can just call it as. So that is how I had introduced the one of the important concepts called getS fgetS, and then subsequently we were looking into the implementation part of the both of the things. In the second slide, slide number 19, we were actually representing a character array with more number of characters that you are reading. That means the buffer is sizing actually more, and then where exactly these characters will go. Even I use the better function, and instead of using the getS function, I've used fgetS function. Still I have some issues. Still I have some error, and then that error is being not being operated properly there in the previous case because of the erroneous code, whatever that was written. In the second code snippet, whatever is given in the slide number 19, that gives a clear indication that you need not worry about your number. So don't hard code is what I wanted to tell. Whatever that you wanted to write, so you write it in a systematic approach, wherein you need not write hard coded thing. For example, some people write A is equals to 100, B is equals to 200, C is equals to 300. C is equals to, to say assignment. So don't hard code. It is a possibility of the end user or the programmer who checks during the runtime. He will or she will pass the argument values during the runtime, and then verify whether this number is being taken or not, and how it's being processed, and all these things. So instead of writing hard coded kind of things, so it is always advisable to maintain such kind of either a constant kind of thing, or you read the data items. Anyways, you are creating an array, so you please don't hard code, but you put as part of a buffer size or some other constant name that you can use and incorporate. All right. So trust you understand this slide, these two examples, because these are playing most important and a pivotal role in current days technologies, because most of our applications are vulnerable to usernames and password. So people are trying to steal your username password. So the moment they steal your username and password, automatically the whole thing in the application, the whole data, or the secured information pertaining to a user or a family or whatever it may be, all these will be into one or the other person's hands, and the third party players will play their own game, and they sometimes they will even demand money to release your data and all such things. So this is how that we must be careful with reference to maintaining the characters and buffer as part of your character reading, as well as the size of an array kind of thing. Right. So I quickly move on to my next slide. So I'm in slide number 20. I hope you are following with me. So I will be talking about the protecting the data. So this is very, very important aspect now. Now today, everybody is talking about confidentiality, integrity, and availability. Uh, is what is called CIA, confidentiality, integrity, and availability. And these are the three important ingredients that serves the information security aspect. So when we deploy an application, or when we are using an application, or when we are implementing an application, or when we are something like that, we are preparing or designing an application, one should make sure that the CIA, confidentiality, integrity, and availability should be made available as part of our security controls. So that prevents unauthorized access. That prevents unauthorized access, but not only unauthorized access, but it protects our interest, as well as it secures our data and integral aspects of our organization. Right. So another way is something like that. So advanced. Now cybersecurity has come into play now. The protecting data is the most important security aspect that come across in cybersecurity concepts. So what that teaches, so you now the issue of bringing some kind of protocols, issue of bringing some kind of secure mechanisms. I mean to say secure mechanisms, they are algorithms, security algorithms, maybe encryption, decryption, or cryptography, or different sorts of other algorithms that you can, use and employ as part of your application development, deployment, and usage as well. So protocols, and then security protocols, and then algorithms that generally focus on more on encrypting, decrypting kind of thing. And then, of course, you can use some kind of hashing techniques, wherein there are a good number of hashing techniques. One of the hashing technique, for example, for reference, is SHA. So SHA is an algorithm where that provides some kind of a secure aspect during the transmission of the data, transmission of the code, transmission of the information, whatever that you can call it as. And it has some bit oriented. It is something like 64-bit or 128-bit or 256-bit or something or the other. So in order to protect your data, so now we need to use certain protocols, algorithms, encryption, decryption techniques, and of course, use some data structures called hashes and other things. So with this background information, I will give you another example in my next slide, in the slide number 21. In the slide number 21, again, I am emphasizing on the strings, which corresponds to the data pertaining to username and the password. So how do you store a password? How do you store a password? So there are different applications now currently available. There are blockchain applications which really protects your keychain kind of activities, wherein a sequence of strings, and combination of strings that will be taken up, and that will be stored securely in order to perform your operations. Look at this code snippet. Typically very, very simple code. You just need to understand what is that I'm trying to explain here. String user, USR is a user, is a string variable, and it is actually requesting the username using the get parameter function. And then password is a second statement wherein you are requesting the password. And then here again you are creating another object for the user. User USR is something like you are just finding out the existing user credentials as part of your system, and then you are checking with your password is equal or not, or username is equal or not, kind of thing. So once it is successful in checking the password, and it gives you the authentication, so you are allowed into the system. Now the same code, and how do we really made it as a secure one? If you can see, the first two statements remains as it is. Of course, third statement also. The fourth one has come up as a new code. The string variable actually taking, it's been assigned with PBKDF2 is something like uh, a kind of security mechanism. It's a package kind of thing, generally speaking, and it checks with the password, and it takes a salt of it takes a salt of iterations. A salt of iterations is, I mean to say, get salt is something like how many number of times that a user has been given to enter wrong passwords. This is what is your get salt. If you give say one time, so after one time automatically, when they enter second time a wrong password, automatically your their I mean login will be debarred, and then they will not be allowed to log in again and again. And if it is two, again two times. If it is three, three times. If it is four, four times. So this kind of PBKDF2 is something like that helps us to understand what exactly we are trying to do as part of our security mechanism to create a kind of security authentication system. It is something like full form, if you want, password based key derivation function. Password based key derivation function. And you know, the two is something like there are variants, one and two are there. So previous days people used to use that PBKDF1. It was not called as one, but now second version was taken as password based key derivation function. This is actually called as cryptography algorithm. In my previous slide I was telling that in order to go for more advanced security management aspects in our code, we have to now employ the cyber security, I mean, algorithms and methodologies. In fact, it is a cryptography kind of algorithm. Uh, this actually, you know, I mean, uh, uh, allow intruder does not allow intruder to guess the passwords. Say for example, you know me, I know Professor Sasikala madam. So I know Professor Sasikala madam's children name, and is madam's husband name, and father name, mother name, their address and everything. I know phone numbers, email IDs and everything. So I can make a try. I can make a try to, I mean to say, I can make a try to, I mean, guess the passwords that were set by ma'am. So now I have this wonderful algorithm, a cryptography algorithm, that is password-based key derivation as part of your cryptography algorithm. So this allows me to use salting, and salting is something like, as I told, like which adds random string to the password before handling it. What is that random string? Random string is something like 200. Random string is something like ABC. Random string is something like XYZ. So something like it. So this ensures the uh, 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 same password will produce a different hashes each time. That means we are making an encryption. Our application, we are making an application as encrypted application. I will just give you an example. I think I am stopping my presentation here, and I'll take you through the, I mean, browser window. So browser window is here, and then you can see my browser, right? So I will just use something called as some website. It is Government of India's website. Can you see my screen here?
Yes, sir. Yes, sir.
Yes, sir. Yeah, thank you. So you can see the screen. So this is one of the live web portal. Actually, it is, I think, DST, Government of India's web repository. I actually created, for the sake of demonstration, I have created my user credentials on this portal. Now I will just log in. So I don't want to waste my time on the registration process. So I will just click on the login button. Now you see, once you come here, so it is asking me to enter the login ID. So let me enter my login ID. My login ID is my email ID. So I'm just entering my email ID. And then it is asking me to enter the password. So I am entering my password. Right? So then now I was asked to enter the CAPTCHA. The captcha code is I am entering now. Now, if you can see, the when I click on the sign in, when I click on this sign in, see. When I click on this sign in, for example, you see the whole password. Actually, I've entered. I'm sorry. I take back. I go back again. Now, what I'm trying to say, while entering into your system, it is converting your password. Whatever the password that you have entered is converting into SHA format as per the SHA algorithm or this whatever the algorithm that I was mentioning, PBK algorithm. The same algorithm will be converting my password into a kind of encryption mode. Again, I'll show you. Again, I will show you, or else you can even try from your end as well. So I am entering my password. So look at this is my password. I'm done. Hardly my password is about 7 characters. Am I right? 2, 4, 6, 8 characters. So my password is 8 characters. I'm entering. So what is this called? This captcha. So I'm trying to click on the sign in button. Now you can see the moment I click on the sign in button, this password is actually expanding this entire text box. That's what the key observation that one has to do right now. I'm sorry because my system actually stores all the passwords if it is required. So that's the reason it's asking me save password and I'm not saving it. So I've logged in. So have you seen that? Have you observed that? If you have observed, you can just post your this thing. Otherwise, I will explain again and again. I will explain one more time, so don't worry.
Yes, sir.
I will explain one more time, ma'am. So this is the one of the beautiful way of beautiful way of incorporating security thing into this thing applications. So now you see the password is it is showing only 8 characters, 8 dots. 8 dots is only what is that it is showing. Now, when I click on sign in button, then you can see a large password. I'm just saying now. Large password. You can see large password that is taken. It's okay. Invalid login, it's okay. But you could see the large password. So this is the code. Even username also being converted as like this. The username is also being converted like this. So if you want, I can open my presentation and copy here. You can just see this. I can just show you my presentation. So you can see the presentation, right? I'm back to my presentation.
Yes, sir.
Now you can see the code QQO, WS, 4Y, DQ, ZS, AW, 2S, FG, 40KM, and so and so, so and so, so and so. So this is the text that was created from your username. Similarly, similar kind of text that will be created from your password. Right? So that is what is the beauty in this algorithm. So hope you understand, and that is how this PBKDF2 has been incorporated, password-based key derivation function. So you please explore this because you don't need to really write the entire algorithm, but only thing is as part of utility packages in your Python or in Java programming language. Unfortunately, it is not possible in C programming environment. I'm not sure, but this algorithm implementation is I have never worked on that. But Java and Python programming and other secure scripting languages, this works well. So this is how that PBK DF2 will work. So hopefully, I think you appreciate this kind of code activities in order to protect your credentials. I just move on to my next slide. I'm just posting you a question. Can you spot the code that transmits data securely? So after having discussions with some 3-4 examples, now I'm posting you a kind of question. Just take some 20 seconds, 25 seconds, and quickly go through the code 1, code 2. I mean box 1 and box 2, and then you can post your answers. Right, so I'm done with my 20 seconds time now. You can just see how many posts are received, ma'am?
Only one, sir.
Uh, what was
The
the
answer,
answer?
post is secure.
Which one?
Post is secure. That is the answer given by participant, sir. Puneet Malhotra, sir.
Oh,
Answer
right.
is post is secure.
Second code, which he was referring to.
And one more
Right.
response we got. The first one is HTTP
Hmm.
and the second one is HTTPS.
Very nice. I appreciate your observation. Wonderful, wonderful. That is the key differentiator in this
So
slide.
that answer given by Krishna Samdani, one of the our participants, sir.
Wonderful, wonderful, Krishna sir, and I think I appreciate your key observation in this code. Actually, coming to this first portion of the code, the first box that represents HTTP, Hypertext Transfer Protocol, and in fact, Hypertext Transfer Protocol is just I mean, it just renders some kind of text into the understandable format by the for the users and all. Wherein HTTPS, it provides security in terms of providing encryption, decryption, and does not allow any intruder to come in between. This is one of the best way that we can explain that. And there is a second issue. There is a second issue. That second issue is something like in the first code, the gentleman has written the code with HTTP myservice.cloud.biz slash login user is equals to something like double quotations USR double quotations password and so and so. So this is a hard coded. So in the program itself, the programmer has hard coded this username and password. So this is not going to be a good part of our code. Wherein in the second code snippet, the same the name of the class or the name of the I mean file or HTML or script file, just like that the name of the script file is being referred, wherein it was not hard coded. However, that portion of the information, I mean username and password, are being actually taken are being actually taken in such a way that by incorporating a method called the post method. So this is connected with this the first response given by one of our professor today. This is a very nice response given by you, sir. Appreciate your patience and active listening. So there are no other corrections. There are no other corrections with reference to code, whatever that we have produced as part of this. But only the case is mm, mm, the data is being sent, and then the sending data is also part of a secure transmission line. I mean, by using the secure protocol. I mean, HTTPS is a secure protocol through which we have transferred the data, and then it's being called the secure data has been transmitted. Right. So another example, I just move on to my next slide. This talks about SQL injection. You might have heard what is SQL injection. SQL, you all know that structured query language. We call it as SQL as well. SQL attacks are most common attacks. In the previous slides, previous examples, we were discussing about the, uh, uh, I mean, breaching of secure information, say username, password, data, something or the other. Now, this is another part of the security breach, wherein intruders can attack your, I mean, the databases. Previously, we were talking about your code. Previously, we were talking about your web application system, whatever the code or JavaScript files or any script files that you have written, they were attacked. They were actually maliciously pushed some kind of code into it and all. But now they are attacking your databases. So through your program, you are asking some query to the database. For example, you are asking a query called select star from EMP, where employee name is equals to Sasikala. So this is a very simple query. Select star from EMP where EMP name is equals to, or E name is equals to Sasikala. So that means I am actually retrieving the information of an employee whose name is Sasikala. It is a fair enough query, right? So there are no issues, there are no challenges. We all know this kind of queries. We have executed 100 times, million times, right? Right now, what is that we have done? We have done something called as hard coded again. That hard coding, we have explicitly mentioned the employee name as some X or Y or Z, right? So if you expose that kind of, sensitive information through your queries, the intruder, that means an intruder who is in between your program and the database. The intruder first attack your program, and then from the program, he is trying to steal your query. And then in that query, he will check and verify what are all the names. As I was telling earlier in the earlier example, I know Sasikala ma'am, I know their family, I know their address, I know everything about them. So I can guess something or the other. Similarly, if I know as an intruder, I know some names or I know personal identities of people, then automatically that leads to certain kinds of, challenges. So similarly, certain issues shall be avoided writing the hard code. So now I'll give you a very, very detailed explanation in the next slide. In the next slide, if you can look at, there are two different codes again given. One I am only marked it as insecure code, wherein select star from users, where username is equal to username and password is equal to password. So that means you are hard coding whatever that you wanted to put in, and then you are sending it to your database. The second and alternate version to the same query is select star from users where username is a question mark. This is called wildcard characters. The wildcard characters are being employed as part of this query, and this query is being executed as part of a stored procedure. You all know that stored procedures as part of your Java programming language and other programming languages as well. Stored procedures are part of your PL SQL, programming language for SQL. We call it as PL by SQL. Some of you might have conducted some kind of experimentation or have explored that kind of thing. So their procedures are part of that PL SQL, because they wanted to emphasize those days. I think 30 years back, 35 years back, that PL SQL was, it was available 30 years back, and now even now people are using the same thing. So 30 years back, they have emphasized the need for the security aspect of that data in the database, and they have employed certain kinds of applicational functionalities for us. Now in Java, we have something called as statements, ordinary statement, prepare statement, callable statement, and all these are part of your Java database connectivity, and JDBC that we call it as. Java database connectivity is something like Java program is trying to talk to a database, whichever the database it may be, whether it is Oracle or Sybase or Syngrace or DB2 or NoSQL, whatever the database it may be, through certain kinds of parameters, through certain kinds of mechanism, right? There are different statements, right? We will first write I mean uh, drivers, installation of the drivers, and creating the connection, and after creation of the connection we will execute the statement. Query can be executed through statement, or prepared statement is something like is a pre-processed statement, wherein we have already created a kind of statements with reference to your SQL queries that can be executed as part of prepared statement and all. So the similar kinds of things are being incorporated as part of our secure code, wherein we are trying to incorporate the fundamental notions of various programming languages, and then we can implement the better way how we can enhance our security as part of I mean, enforcing the security as part of our application design, development, and deployment, right? So, in a nutshell, this what I would like to convey out of this SQL injection issue is SQL injection is a most critical and dangerous vulnerability and that has actually come from our own way of writing the code. Our own way of writing the code means not following the standards, not adhering to the secure coding principles. Because of that, and due to which our SQL queries are prone to hack. And how do we prevent that kind of vulnerabilities? Is very simple. We can use two different things. One is as I said, like a pre-compiled query, by putting something, all code, I mean all SQL queries, putting inside into something called a prepared statement or a callable statement, and then execute from there, is what is one of the best way. Otherwise, also the binding of parameters, and parameter binding is something like while writing your, I mean, question mark, colon kind of thing, or percentage kind of thing, and then you can supply the placeholders. I mean, question mark or percentage, or whatever that placeholder that you kept through your execution parameters. So while you are executing your application, you key in the details instead of you are writing it on a hard-coded one. So these are the two alternative mechanisms, but suggested mechanism is something like the pre-compiled query, as I was conveyed in the secure code example. So this code is most preferable, but it's not that great code. It's part of every single programming language, but only thing is our mindset towards writing our code, that creates a kind of distinguishing, I mean, identity between unsecure code to the secure code, right? So I just move on to my next example. So this example, this is also one of the most happening, I mean, threat, most happening, most created vulnerability. We call it as cross-site scripting. Cross-site scripting is something called, also called as XSS. Cross means X is indicated for cross, and site scripting. What exactly happens as part of this cross-site scripting? This diagram is absolutely a beautiful diagram that explains everything in a very clear and nice way. So registered users are connected to their own trusted sites in general. I mean, the users, whoever is the user. Here we mention it as victim, the person who is actually become victim because of malicious scripts that were pushed by the intruder or the hacker. What happens, hacker injects trusted website with malicious scripts. So predatory websites. Predatory websites are something like that. A copy of, I mean, it looks like, it resembles like, it looks like a SBI website only, or your ICICI Bank website only. But it has some kind of issues. So a copy of the website of ICICI or SBI is being taken, and then this fellow hacker will create another site of similar nature. And the moment you try to, I mean, visit that particular site, and the danger, while Googling, that is the danger. While Googling it, generally we have trusted sites which are actually stored as part of our browser, right? So we can say that this site is trusted site, and we can keep that trusted site as a one of the, I mean, identifier to visit. I mean, in future, whenever we come and we try to access that particular site. But when you are searching through Google or some other search engine, you type something called ICICI website, then or SBI website. It gives you some information called another website, which is most similar to that of, So you never even, I mean, identify that whether it is original or genuine website, or we are trying to going out of the website and all. So you key in your details. The victim enters into the website, and he clicks on the different links, keys in his or her credentials, and then the moment you enter, automatically a cookie file, as I told you yesterday, a cookie file is generated. That cookie file will be captured by this hacker. From the time when the cookie file has been hacked, I mean, taken by your hacker, he or she will have the complete information that what about the transaction, how is that you have logged in, what are your authentication details, everything will be taken care by this hacker, and he will enter into your original site and he try to attack on your data or try to steal your money or try to transfer is your money to some other accounts and all. This is how the whole things are happening. Even these days, hardware is being also being uh, swapping. I mean, hardware is also being swapping from one mobile device is being swapped with another mobile device, and then automatically the message that you are getting on your mobile phone will also be received on the other mobile phone, so that that OTP, I mean to say, not message, OTP, one-time password. So the same OTP is being used by the hacker to steal your money much before you enter. That fellow will enter and steal your money. So trusted sites is one of the key essence as part of this cross-site scripting. So that plays a key role. That plays a key role in managing or in making what I mean to say, uh, making or even preventing to come out of that kind of cross-site scripting vulnerability. Right. So I can move on to my next slide. I will explain further on this. Right. So more information, more textual and programmatical examples are given as part of this particular slide. So it is self-explanatory, so probably I don't need to explain much about it. Okay. However, to prevent your cross-site scripting, there are keywords, I mean, which we need to adhere to, which we need to take care of. Certain kinds of functions and elements are part of HTML. So avoid writing inner HTML, avoid writing SRC. SRC is something called source, wherein you are locating a picture, you are locating a file, you are locating some audio kind of thing or video kind of thing as part of your HTML code. So certain things can be dangerous, and then on click, on load. These are all some of the, best examples that we need to avoid. And functions, if you look at evaluation function, set timeout function, set interval function, most of the set functions are absolutely ridiculous functions which actually create danger to your code, right? So most of such excesses will happen through your scripting languages. Like JavaScript is the most dangerous scripting language, which always prone to hackers discretion. So hackers can always attack on your JavaScript code, even JScript as well. So that's how all these open source scripting languages have come. And today you can enforce security in Python or PHP or any other the framework, but otherwise it's not possible. However, to add security flexibilities to your JavaScript or JScript, you need to plug in some kind of frameworks. Those frameworks you might have come across AngularJS kind of framework or React framework kind of thing. There are a good number of other frameworks are also part of it. So certain frameworks that you can, I mean, I mean, uh, uh, incorporate, as part of your JavaScript to make the scripting more secure. Right. So another coding example on the cross-site scripting. Again, like the other way, how I was presenting your previous examples, the similar way now I am presenting the cross-site scripting example with the two code snippets. Look at the code snippet first one. It's just taking, it's a form, a kind of form that we are developing, where there is a label in the first line. If you can see, there is a text box, input type text, which I was referring to yesterday, which is one of the most dangerous control in HTML. And then there is third line is talking about submit button kind of thing. We are creating a button and we are writing on the button saying that search. That means a search kind of functionality I'm creating as part of my form. Look at this mm, mm, advanced, I mean secure code, pardon me, advanced secure code. Look at this, again the same way, there's no change in terms of the functionality of the code. Initially we have created a div, I mean a division in the form, and then there is a label followed by a text box and then followed by a submit button, and then again a div class is created, and then there is something called percentage equal to request dot get parameter to search. Here second code, percentage equal to string escape utils dot escape html4 of request dot get parameter of search. So instead of writing just like that request dot get parameter, request dot get parameter is just trying to take what is that called the search in the search button, what is search text box, whatever the key that you have entered, it is automatically capturing whatever that you entered here in the first code. For example, my search box, my text box contains the name of the search item is ATAL FDP. ATAL FDP is my search item. So I have just entered in the text box and there is a submit button. So I am clicking the submit button, or submit means search button. I'm just clicked on the search button. So some functionality will work here. There is no error in this code number one. Coming to the second one also performing a similar, what is it called? Similar functionality wherein I am searching something, where I'm searching something called whatever that I have entered in the text box, and the same thing is being taken up, but by writing the additional code controls, additional code controls. So what is that additional code control that I've used? Is something like escape character manipulation. Escape character manipulation is something like, which is very, very important, which has come from the Apache web server. Absolutely speaking, it has actually coined by the Apache web server. Apache APACHE is a web server. So that takes care of executing your applications, your programs as part of web application repository, right? So what that contains, it is basically a string escape utils dot escape html4 is a static class, and it is a wrapper class. Actually speaking, it provides the string builder. I mean, string builder, why we need to have this string in simple way, why we should have the string escape utilities class is, there are reasons. I searched something called ATAL FDP. It is only one word, ATAL FDP. ATAL FDP. So there are only 7 characters in that. Right. Now, what is that? The termination character after P. Have you written any termination character after P in the first example? No, we have not written. No, the reason why, because we never write as a user, we never write. Even in the Google, any other search engine also, we just type something called, if I want to search about me, you type my name and just click on. But there is no string ending character. Unlike backslash character that you put generally, \0 in C language to represent, that is the terminal string. That is the terminal for the string. But here you should have some kind of similar functionality to terminate the string. Otherwise, your intruder or your hacker will prone into your, attack into your application, and he will add his own search items. So ATAL FDP is what my key is. He will add another word or another character or another 2 or 3 characters, so that he will find something differently with reference to different case. So So this works only with Java, my dear friends. So the Java or any other scripting languages, only this works. So this will Java, this we call it as Java escaping feature. Java escaping feature, this provides the functionality to have a deprecated functionality. So, and then this functionality will allow you to not to intrude any fellow, and then not to allow anybody to add their own, and I mean to say their own characters or strings kinds of thing at the end of your what is it called, your string, right? Otherwise you can provide mechanism in the code. This is one of the way. Otherwise there is an alternative way for you, is something like you can write an escape character. That escape character, so for example, user is entering ATAL FDP. Now your code shell contains something called a backslash escaped characters for you. Those escaped characters you can code as part of your scripting language program code, or any of the other programming language code. So then you can control that kind of intruders attack into this particular code. Right, so this is what is called preventing cross-site scripting as part of implementing as part of HTML or any of the scripting language codes. Right, so this another example probably I'm taking up. So because of the time constraint, there are, I think, plenty of examples. There are about 17, 18 examples that we can cover as part of the secure code. However, I'm given very less time, so I could restrict myself to very few examples. So I will just at least elaborate on what are all other challenges, what are all other possible vulnerabilities that we can expect as part of this secure process. Open redirect. Open redirect is one of the vulnerability that is happens through a URL. In general URL, what generally we will write, so URL, full length of URL that we'll write, including slash, dot, backslash, a, small a, capital A, B, brackets, parentheses, square brackets, and so and so, so and so. So that actually leads to an open redirect issue. Right, so in certain situations, what we basically need to use, open redirect can leads to the phishing attacks. Phishing attack is something like they'll attack onto your websites with their code, and they exploit the kind of this kind of uh, vulnerabilities can be generated out of it. So in a simple way, it is actually called a secure flaw. It is not actually, of course, we can manage through code also, but however, in a larger picture, larger perspective, it is a secure flaw actually that allows your hackers to redirect the users from trusted sites to, bad sites. Bad sites are being created by them, and they use a kind of other example also I have told. Similar sites that they generate or develop, and they will transfer your and they reroute you into the bad kind of sites, right? So with this they actually they direct you to into different kinds of malicious sites, and they try to attack on your code, your data, and all these things will happen. But how do we control in this scenario? There are, I think, 2-3 ways to control it. One is that is our user input, whatever the user input is there, which shall be validated before we go into the site. I was giving you an example that encryption decryption is the best way of mechanism that is possible through your HTTPS protocol. HTTPS protocol is a transfer secure protocol, hypertext transfer secure protocol, and wherein we can convert your user credentials into binary format or encrypted format, which is not understandable by any intruder. Second way is something like the redirection redirection function that we can avoid as part of our coding. So that means any intruder is coming and trying to redirect automatically. It tells the user saying that you are entering into a untrusted site, and it gives you a message alerting saying that you are trying to move to say third party application, wherein the third party application is actually a hacker application. So you must be careful moving from this side to another side. And also, these days, another mechanism that has come, all the URLs, I mean, trusted URLs, whatever are there, they will be maintained as part of one of the file. I mean, file in the sense hash file, so that hash file creates a kind of a trusted websites. So the moment user tries to connect to a site, it checks in the trusted website repository, and if it is same, then it gives access to a particular user. Some browsers like Safari prevents such unauthorized intruders. Safari prevents such unauthorized redirects. Most of the cases, 90% I'm saying, but not 100%. But that is one of the way. And Google Chrome is being coming up with the different plugins wherein it is also trying to protect your own data for redirecting from one site to a bad site or untrusted site kind of thing. So this is about the open redirect. And look at the example. So again, a couple of examples are given. In this example, the first example, uh, so other provided one URL, that URL is being transferred and it is being taken from get parameter method. So very simple. The first line is over, and second line is something like redirecting to the same whatever the URL that is being captured. Now this is the dangerous thing. Now while you are redirecting, what will happen? Again the intruder fellow will come and add a dot or comma or a special symbol. So he will, I mean, moves into takes into another source. So this can be rewritten something like this. In the second example, I think first statement remains as it is, and then the second statement, if you look at, there is the good change in the second statement. Again, URL is being actually taken up. URL is being taken up, and then there is some kind of functioning methodology that is being provided as registered other provider. So registered other providers is something like that protects. AUTH is other actually. Yeah, provider, that's something like that provides some kind of security mechanism in order to access, in order to maintain authentication with reference to this thing. So I will give you a clarification on that. What is this registered other providers? So this is something like every browser will have their own API, will have their own API. I think if you can check it in any of the browser or Google it also, you will get to know some kind of this thing. There is something called Google Authenticator. There is something called Microsoft Authenticator. Microsoft Authenticator is a multi-factor authentication which works with Microsoft browsers. Whereas Google Authenticator is something like it works only with the Google authenticators. And there is something called RSA Secure ID, wherein that works with RSA devices, secure devices, and of course for IBM sites in general, corporate sites, if you look at, there is an IBM Security Verify. Certain examples are possible. These are called APIs, which are being maintained by different kinds of organizations, enterprises. Then key clock is the one which we generally use. Key clock is the one which our organization use, which provides single sign-in capabilities. Single sign-on capabilities means once you enter into, enterprise network, so one time sign-in is enough. So not all the time you just need to click on username, password, and all. You're not really allowed to access certain kinds of thing as part of your application access. So registered other provide you some kind of functionality with reference to their API, and every browser and every application, every enterprise has their own kind of applications APIs for that. right? So another example is something called uh, authentication bypass. Authentication bypass is most dangerous vulnerability. Uh, what exactly, it happens, it is more or less similar to the previous example. In the previous example, it is a redirection kind of issue that was happened. But now, uh, in this case, what happens, attacker bypasses uh, uh, your mechanisms from one device to another device. I mean, one say source to another source. So, for example, in simple case, there will be access procedure for every application or every public website. When you have certain access procedures, generally we follow the same thing, and our protocols also allows to browse the systems in such a way. Otherwise, we will not be in a position to access certain kind of things. But here, the attacker, he will change the entire procedure. The process or the access procedure, what I conveyed earlier, he will just change the entire procedure, and he will push that procedure to us, because when we are accessing that particular thing, we should have to follow. So our navigation shall go. In general, what we do, we enter username, we enter password, and we click on submit button. So before we click on submit button, whatever that we enter is being captured by the user or hacker. Whatever we enter as a password is being captured by the hacker. So that's how, before we even submit, before we even go for a live implementation of that, while entering itself, the data is being automatically taken up by intruders, right? So the moment the attacker takes this data, a bad fellow, or bad user will access that particular application, and then they will hack every sort of information from your mail or your personal content, or personal textual information, or graphical, whatever it may be. So this is one of the other example that we can come across. And then missing or incorrect authorization. So this is also another example. So it is more or less similar to that of authentication bypass. So instead of validating the roles and permissions, people are accessing into different ways to get into admin privileges or any other super user privileges and kind of stuff. So for example, you are given only a customer privilege in a bank, but you wanted to access the manager privilege. Yes, you can access. That is how we can call it as incorrect authorization kind of thing. So intruder can do, and such kind of possibilities are absolutely possible in this scenario. And moving on to next slide. So I think it's already 9:18. Okay. I have one or couple of slides for me, so I'll complete it quickly, and then we will open for Q&A. So download of code without integrity check. So this is very, very important. Integrity check is something like it is to be verified whether you are correctly downloading the required content from the public domain. Correctly downloading required content from the public domain, because you will never know. Generally, the malicious script, malicious code are in the form of two or three most important formats. One such important form is a zip file. Okay, so that file, anything can be compressed into it and can be exported, whereas the executable files cannot be transported over the network. Most of the secured browsers as well as the email clients, they prevent transferring, executable files or kind of thing. And in these days, the one of the vulnerability that we are hearing is something like APK files, wherein mobile applications, when you try downloading it, once you download it, automatically your device will be in the control of an hacker. So he can do anything and everything. So it is his most dangerous kind of thing. So certain files, you please do not try to download, or if you try to download, you should have a kind of firewall mechanism in place. And when there is a firewall, that firewall prevents your unauthorized or the dangerous code, or the code which is not permissible to come inside your organization or into your computer, kind of thing. So this prevents certain kinds of uh, uh, vulnerabilities by enforcing the best practices, which are called maintaining the key policies, hardware updates, and then having certain software applications which checks the code whether it is malicious or not malicious, or kind of thing. So this is one of the other possible vulnerability that we can come across. And this is, I think, another example. This is missing of encryption with reference to secure data. So this is again something like your database is being hacked. So without being coming from your application, intruder or hacker will directly come to your database, attack your database with the user credentials, and the data breach will happen. I heard in the recent past that there are a good number of students, they have hacked a university examination system portal, where they entered their own marks. I think they might have failed in the exam. I'm not sure, but they hacked their database of examination server, and then they have changed their own individual candidates marks. So and maybe after some time, the concerned faculty members, they identified that these fellows are having good number of backlogs, and finally in the result sheet it is saying that zero backlogs, and all. How could it be? So then the investigation took place, and then they've investigated them. Finally, they have accepted that they have attacked the database, because the database is running without secure protocol levels. There is no firewall. There is no secure code mechanism that has been part of enforcing the database security, program security, and so and so. So these are such certain type of sensitive data can be hacked when it is not being encrypted. Example I can tell you is SQL Server have an encrypted mechanism. So if you can enforce that algorithm, the secured algorithm, SSH algorithm, then automatically your usernames, password, every single damn data that you store as part of your tables will be encrypted. Even administrator cannot even see what exactly the username and password of an individual user. He or she can see only the hexadecimal code or machine code that can be presented as part of it. And then another example is something like untrusted inputs. So this is a simple validation only. Client can validate this kind of data without being really investigating into the problem. Right. So there are other ways of mechanisms are also given, and then yes, yesterday a couple of questions were asked on what is the good book that I can follow for to implement secure coding practices. So this is one of the best book that I have come across. Of course, the very old version that is available in the market in India today, international market, I think you can get this book. Second edition is what is the best book that I can probably say, and it costs around 2,500 rupees or so. Is the best book, and there is online repository, Microsoft Developer Network Security, so wherein you can access certain secure information from them. And there is another Microsoft Patterns and Practices. So this is also the web link that I am sharing. So you can even refer to this information for better understanding, for better uh, implementation of coding practices. Right. So I think I am done. It's 7:24 now. So if there are any questions, I'll quickly take up.
Participants, if you have any queries, please. You can ask through voice or even by chat box. Sir, one query we got from Munir Ali sir. Can you please drop the name of the book, sir?
I will share the presentation, madam, so that you can even take. So it
Yes.
is
Okay.
Microsoft. No, the book name is Microsoft Publisher Writing Secure Code.
And sir, one more
Right.
query we got from the participants, sir.
I will even type 1 second. One second.
Okay, sir. Here, one more query, sir. Any techniques to find the malicious data while downloading PDF or before downloading PDF?
There are so many techniques that are available, ma'am. One such thing is being enforced by your browser first. So, whichever the browser you are trying to use, without our intervention, it checks the browser by default checks whether this particular code is something. Uh, Having malicious code or virus code or something or the other. So that way, it prevents any kind of files and alert saying that dangerous script file or dangerous file kindly do not download, and certain kinds of messages will be given. Otherwise, around there are certain mechanisms that are incorporated as part of your application itself. In those cases, applications checks the vulnerability in files. I mean, that is the reason FTP sites are not being accessed. Most of the organization, they have their own policy making things, and they do not have what I mean to say, like kind of policies that do not allow these kind of files or malicious files to download. And also there are levels at the firewall as well. Firewall also prevent the kind of traffic that is coming in and kind of files that is coming into this kind of network. And even nowadays, your internet service providers are also uh, uh, providing certain kinds of the security mechanisms to prevent such files.
Thank you, sir. Any queries still? Participants, if you have any queries. Sir, one more query. Is there any code analysis tool that can detect any kind of loopholes from the security flaw?
So two things are here. One thing is you're asking for code, and the other thing is it's a manual one. Code, it is in an investigation. What is revealed, the automated tools are investigated. The errors, issues or the challenges or the bugs or the flaws for about 70%. Whereas in manual kind of review, the uncover rate, the kind of error cover rate could be around 90 to 95%. So that's how many organization predominantly depends on the manual kind of thing. However, there are automated tools available, but which are not provided as part of freeware kind of thing. So they are proprietary kind of thing.
Okay,
Thank
sir.
you,
Thank
sir.
you.
Participants, sir, which antivirus software is a good to prevent such virus while browsing times and download any files?
So I cannot say, but any antivirus works really well because antivirus has certain standards. They get certain kind of ratings by the ISO organizations. So based on the ratings that they will work. But most of the antivirus softwares are really good, and but only thing is you just need to update and upgrade the latest versions, revised versions from them. So all the time you just need to connect with them. All the time you need to subscribe to one or the other antivirus softwares to make your applications and data secure.
Okay, sir. So one more query, sir. Grid computing programs for lab for cloud security theory. I think that question is not proper, sir. Sorry. One more question from Dr. Nirmala, ma'am. A basic textbook that can be recommended for students to cybersecurity and digital forensics.
No, no, 1 second. I understand. I understand the question. We were given grid computing programs for lab for the cloud security theory. Wrong, madam. Cloud security theory is something similar to this, the way that I have presented it today and yesterday. But your grid computing application programs or something, cloud computing, you can use those one or the other applications, but cloud security is something different. So please change your syllabi. Otherwise, it will not be appreciated by many.
So, is there any preferred books for grid computing, sir? I mean, one of our participants asking.
Yes, there are good. I think you can refer to one book by just 1 second. Grid computing. You are talking about. I was referring to one of the book. This is something like distributed computing by Cambridge University Press. There is one book that is very good. DCS book that we call, and it is available even online also. I'll just share you the link. It is available even in online mode.
Okay, sir. Participants, if anyone wants to give the feedback, you can. Shashikala ma'am, shall I continue, ma'am?
Okay, ma'am.
Okay. Sir, Sudhir Reddy, sir, with your permission, shall I carry on, sir?
Yeah, please go ahead, ma'am. Thank you very much.
Good evening to all. On behalf of SRIT management, participants, and organizers team, I feel honored to express our heartfelt gratitude to our esteemed resource person, Dr. K. Sudhir Reddy, sir, for his invaluable contribution. Sir, your presentation on secure coding, importance of secure coding, support secure development lifecycle, role of developers in ensuring secure coding, and especially in today's session, knowledge contribution in code snippets, in SQL injection, and many more topics we learned from you, sir. Thank you, sir. And your vast experience in cybersecurity really shone through, and we are truly grateful for the time and effort you have taken to share with us, sir. We
Thank you very
understand the
much.
value of your time, and we sincerely appreciate your have taken time of your busy schedule to be here with us today. We hope this is just the beginning, long lasting relationship with you, sir. Your insights have been invaluable, and we look forward to future opportunities to learn from you, sir. Once again, thank you so much for your excellent sessions yesterday and today, your expertise, and your willingness to share your knowledge with us, sir. And especially interactive session by sharing the code, by asking the questions, or etc. We are grateful and look forward to applying all that we have learned today. Thank you, sir. Sir,
Thank you very much. Wish you
participants,
all the
Thank
best.
you, Sudhir Reddy, sir.
please
Thank you.
switch on your videos 1 minute, sir. We will have to take a group photo. Participants, thank you, sir.
Thank you, sir. Sudhir, sir. Thank you.
Thank you very much.
Sir, thank
Thank
you,
you,
sir.
sir. Thank you very much, sir.
Sir, one more question, sir.
Yeah,
Cyber
please.
security students are very interested to join in that course. Is there any
Yeah.
good opportunities are available in India or abroad?
India, it is available, ma'am. There is no point in going for abroad for that. But the only thing is, they should look at good course with reference to the content and the availability of instructors, the faculty or whoever the instructors are there. So they should look at them, and
Madam, Sunit.
probably they can look at certain kinds
Hmm.
of programs and the institutions.
Okay, sir. Thank you.
Okay. Thank you, Sudhir Reddy, sir. Thank you very
Thank
much, sir.
you. I'm disconnected now. Is that okay, right?
Yes, yes, sir.
Very much.
Thank you. Good evening, Balaprasad, sir.
Good evening, ma'am.
Good evening, sir.
Sorry for the delay, sir.
No problem.
Sir, I would like to welcome you to the third day of ATAL Online Faculty Development Program on Cybersecurity and Essentials and Digital Forensics, sir. So before I hand over the session to you, I request Sunita madam, please present the brief profile of Balaprasad sir to the participants, ma'am. Sunita madam.
Madam, shall I?
Yes, ma'am. Kamakshi madam.
Okay, ma'am. Thank you.
Ma'am,
Good
is
evening,
it
Balaprasad.
audible, ma'am?
Yes, ma'am. Yes, ma'am. Sunita ma'am.
Yes, yes.
Ma'am, is it audible?
Yes, ma'am. Sunita ma'am.
Yes, yes.
Yeah, ma'am. Thank you. Good evening. Good evening, all. I'm Sunita, Assistant Professor, Srinivasa Ramanuja Institute of Technology, and I welcome to the session on security, on software security. So I welcome Mr. Balaprasad sir. Our session, our current session handled by our industry expert, Mr. Balaprasad sir. Sir is a Chief Innovative Officer and a Global Head, Tata Consultancy Services, Mumbai. Sir, we are very happy and delighted to have you here, sir. I would like to brief out a few things on achievements of Mr. Balaprasad, sir. Sir has 23 years of experience in industry, and he has been a leader and a practitioner in building high performing product development. And sir has worked in various product domains, domain areas like artificial intelligence, enterprise architecture, cloud solutions, design thinking, DevOps. So here the list goes on. Modern workspace, performance engineering. So those are the key areas where Sir has worked. And Sir has been in connection with the IEEE, CSI, Internet Society, and Open Group. So Sir has been in connected with various university and engineering colleges, and Sir has been driven and continuous related to the student community, and Sir has been as a secretary of Internet Society India Hyderabad chapter. Sir has been as a co-chair of information technology. Sir has been as a board of studies member of various CSC branches and newly defined branches under artificial intelligence and departments. Sir is well aware of the student community, and Sir is aware of the board of studies which are defined in the various autonomous colleges. Sir has worked over 23 years and has been as a principal consultant and transformation innovator in Tata Consultancy Services, and has been leader for high tech unit. Sir is presently as in a role of a transformation innovator in Tata Consultancy Services. Sir, we are very delighted to have you, sir, and welcome you to the session, sir.
Great. Can I share my screen?
Yeah, sir.
Okay. Please confirm if you are able to see it.
Yes, sir. It is visible, sir.
Just a minute. I want to change the slides. You're able to see the change in the slides? Okay.
Yes, sir.
Okay, fine. Okay. Thank you, SRIT team, and I welcome all of you for this faculty development program on security. So, how many of you strongly believe security is a before thought approach, but not an afterthought approach? If you question yourself in this particular area, software security is always a before thought. Whether it is an architecture, whether it is a design, or any part of the software development lifecycle, people need to think about software security right from the beginning. But if in the reality, you try to see that most of the development constructs only talk about the functional aspects, but does not talk about the non-functional areas. And whereas one of the important ingredient on the non-functional requirement is the software security. And in the real time, if you try to look at, there are so many threat vectors which comes into the existence. You might have seen so many companies getting compromised on their data sets, so many companies losing some of the valuable data, primarily because their applications, their databases are not foolproof. So it's very much necessary for all of us to prepare the next generation of the secure coders. So coding is not only about achieving the objective, but also achieving the objective in a more secure and performing way. So with that note, I just wanted to bring your attention, what are the key objectives we are going to cover as part of this particular session. So we need to understand before getting into any particular subject, I believe some of the speakers might have already told about, but I'll try to share from my perspective. It's very important that you understand the evolving threat landscape. Threats are so much today that the more and more digital we become, the systems will become more vulnerable. So in understanding the threat landscape is very, very critical for us. The second important thing which I'm going to touch upon is how do you secure or develop or learn secure coding principles across a secure software development lifecycle. That is very much essential because at each and every stage, understanding the nitty-gritties and some of the known areas will really play an important role. Some of you might have already been exposed to the OWASP, which is a open worldwide application security projects. They normally provide a lot of content and around the software security principles. Following that will give us a very good understanding about what are the new threat vectors which are getting emerged, which we need to be aware of. Since it's more on the digital forensics and cybersecurity essentials, I felt it is important for you to touch upon the exploring the basics of digital forensics. Obviously, there are speakers who are going to get into the details, but I'll share my words of wisdom there. And integrating, finally, I'm trying to touch on the integrating the cybersecurity into the teaching. How does it really play out? Just to brush up the thoughts, before getting into the cybersecurity landscape, I'm giving you a kind of a 30 seconds for you to read through this particular material. Basically, trying to talk about software security definitions which are coming out. So when you try to look in from the overall security landscape, how do you define software security? You say that software security is a visible entity or an invisible entity. Is it only protecting the data and the resources around it, or you need to also drive a lot of control around it? How do you try to build that kind of a trustworthy capability into the entire application security, which can make this software more robust? These are the things today, when you try to look into the Wikipedia or any of the prominent books, they try to bring out that it is a discipline in the software development that helps to ensure that each and every component in the application or the product landscape or product stack adheres to the certain set of secure principles or guidelines throughout STLs. These are essential because you need to resist, you need to tolerate the kind of an attacks which are coming in. And that requires you to continuously monitor the things and continuously ensure that you are able to safeguard and put down the real measures. So how do you bring out the composition of the security into the context? Probably you might have touched upon, I don't know, but I'm just trying to think hard that these are the 4 important foundations you might have been already touched upon. And if not, probably these are the very much important elements to look at. One is confidentiality, which is trying to see that a process which will allow you to authorize the users, which will have access to the authorized information. The second is integrity, very, very critical and important, because whatever the data you are trying to use, whatever the information you are trying to consume, that need to be accurate and complete. No manipulation need to be happening. Third important element in the CIA triad is availability. It is a process to ensure that all authorized users will have access to information as and when required. That's where your authorization and authentication plays a very important role. Fourth, very important element as part of the security foundation is to re-establish the facts so that with the participants or stakeholders or actors, so that we are unable to repudiate or deny an act which has occurred. So there is a accountability or a kind of a mechanism to track all those things. Having said this, it's very important that I try to bring out some of the evolving threat landscape in the digital battlefield, which you need to be aware of. So I just want to bring your attention to this three important elements. Whenever you're looking at this threat landscape, cyber espionage, activism, and state-sponsored attacks. These are the three important elements what you need to be aware. If you are a faculty teaching to your students, continuously knowing this particular terminology and taxonomy plays a very important role, because these things gives a kind of a very distinct view how often this interlinked and malicious attacks can really drive the change. So they are coming with a specific set of participants and tactics which are really posing significant challenges for the organizations. And not only organizations, but also for the governments which are trying to protect sensitive information and maintain stable digital ecosystems, what you're really looking at. If you simply look at the cyber espionage, basically it involves a covert gathering of sensitive data such as intellectual property, diplomatic communications, or strategic business plans by any unauthorized parties. The attackers, generally what happens is they are well resourced and highly very skilled and employing very, very stealthy techniques to remain undetected for prolonged periods. They sit in your environment and they capture the things. So what happened in one of the interesting stories in 2020, there was something called Night Dragon attacks which happened. So which targeted the global oil and gas companies, where hackers infiltrated the corporate networks to steal information on energy discoveries and plans, and giving this information to the competitors or even to the foreign governments for an undue or unjust business advantage. There's a second example in the cyber espionage I want to give is about the Cloud Hopper. This is a huge campaign which happened. Reportedly, it started linking it to the state-backed groups, compromised a lot of managed IT service providers globally to access the trade secrets of many, many client organizations. This is prominent from the cyber espionage angle. This is important for you to understand. The second important area is activism. It is a kind of a threat in the entire digital battlefield landscape, where it merges with the political or social activism with hacking. Instead of directly or pursuing the financial gain, these attackers, what they do is they aim to advance a cause, expose wrongdoing, and protest policies and organizations which are very, very unethical. They often rely on a lot of website defacements, data leaks, distributed denial of service attacks to draw public attention. So these hackers, generally what happens is anonymous, and they conduct a lot of numerous operations in support of various social and political issues. For instance, let us say they can take down your website of governments or corporations and often publicizing their motives and demands. So this kind of an attackers also can get associated with any kind of a environmental harm, which can really orchestrate activists to seek and highlight injustice or force any kind of a transparency. These are some of the things which are coming in the activism area. The third important attacks are carried out or supported by nation states. They're often as part of the broader geopolitical objectives. They can target critical infrastructure, rival government agencies, or strategic industries. The reason I'm trying to bring out is these are considered as the advanced persistent threats which can achieve long-term covert access. So one of the popular threat which happened long back, a decade ago, is about a Stuxnet worm, which really infiltrated the Iran's nuclear facilities to physically disrupt the entire space. So this is one of the operations which has been marked as one of the first known cases of cyber activity causing tangible and real world damage. In another example, in 2017, I believe just before the COVID, NotPetya, which is a malware alleged link, it was linked to the Russian interests, struck Uranian infrastructure, and then spread globally, causing large-scale financial and operational damage to companies and public services around the world. Similarly, the Nimda virus was also something of the same nature. So why I'm trying to tell is, by understanding the nature and motivations and examples of this kind of a cyber threats, organizations and governments can better tailor their defense strategies and strengthen their cybersecurity strategies and enhance collaboration across sectors to mitigate risks. This is very, very critical, and we often see this digital battlefield drive that kind of a changes, and understanding this threat landscape is very important. But is that enough? You also need to understand the threat vectors associated. Probably you might have heard about these three terms: ransomware, phishing and social engineering, and supply chain attacks. I hope you have heard about it. If you have not, probably we'll try to touch upon it. So ransomware, phishing, and social engineering or supply chain attacks are some of the common methods used by the cyber criminals, where it tries to attack the computer systems, steal the data, disrupt the operations, and they have their unique tactics and targets and their different consequences. So ransomware is a type of a malware that encrypts victims' files or entire systems and demands. They try to demand payment, often in the cryptocurrency. That's what the Bitcoin is very much famous for, because it cannot be tracked further. And it can spread through malicious email attachments, compromised websites. Probably so many of you might have seen such kind of emails coming in. So once it is inside the network, it quickly looks critical files and brings operations to a halt, leaving victims with a very, very difficult choice of making the payment. That's where your backups, that's where you're protecting your files. Critical files are very, very important, so that you'll be able to restore the systems without compromising on the ransomware attacks. The popular ones which I want to touch upon is the WannaCry. See, this ransomware spread across the globe. So many people got exploited, and it is a known security vulnerability in Windows system. It hit organizations worldwide, from hospitals in the UK to the large corporations, demanding a lot of people to pay cryptocurrency payments. Otherwise, they were compromised on their data sets. It's people who were able to get the data protected, data backed up, were able to come out of that situation. But people who couldn't, they need to make the payments to get back. Instead of making the payments, they would have not got it, their data back. The scope and speed which really forced these institutions did a lot of disruptions across the world, and it really talked about the kind of a loopholes in the unpatched systems. The second important threat vector in the example I want to give is a NotPetya, which I already mentioned. This is more destructive in nature because it has encrypted the systems and demanded a ransomware. So if data is completely encrypted, you cannot make out anything. It is not recoverable, and it really targeted that Ukrainian firms at that point of time. It really devastated a lot of information and sabotaged the operations in the Ukraine. The second threat vector which we need to be aware about is the phishing and social engineering. Social engineering, I believe everyone is aware of. People will be with you. They try to attack, capture your passwords, or attackers can craft emails or messages or phone calls that chat legitimate. So probably you might have seen nowadays many people getting calls from TRI, many people getting calls that I'm calling from Telecom Regulatory Authority of India, or people calling from customs and saying that you have a unauthorized goods stuck here, you need to make a payment. Like so many such kind of a very, very believable people try to call and try to cheat you. So this is a kind of a area where you try to normally get into that, and they try to trick individuals and reveal and extract the sensitive information and try to grant access to the unauthorized information access. So phishing emails is one of the important area when you try to get an email. In fact, I'll just give you an example what happened in TCS. During the course of April-May time, we wanted to spread the security awareness across TCS, and there is a phishing email which we sent from a kind of unauthorized, from a account which was created, stating that here is your performance band grades, because that was the time when our yearly performance bands were released. We wanted to know how many people in the company would go and open that particular link without even checking the email ID, the source of the email. And that is as part of the awareness campaign to ensure that we are aware of the social engineering and phishing attacks. And 98% of the organization went ahead and clicked it. It's an indication stating that people don't look at the source of the email. A typical phishing attempt might involve an email from what appears to be a very, very trustable source, but that they try to give it as CO or IN, something, a little change, and we don't try to spot. So verifying that account is very important, and verifying the source is very important so that you know exactly from where this particular thing is emerging. Spear phishing is another variant within this phishing area where you can target variant, and spear phishing zeroes in a specific individuals in the organization, personalizing the message which is very much to that particular person so that it increases the credibility. Say for instance, a senior executive might receive a call or well-crafted mail they can send that seems to come from a very trusted partner, prompting them to share some of the sensitive information. In fact, recently, one of the interview, Sunil Mittal was trying to refer that someone was mocking the voice and sent a kind of voice message to a particular person in his organization to transfer some funds. So these are some of the phishing and social engineering attacks which are happening commonly. The third important threat vector is the supply chain attacks. So these attacks focus on the relationships between the organizations and their trust third-party vendors. And one of the popular area where we have seen this happened is a SolarWinds attack. So because it's a malicious actors infiltrate the software update system for a widely used IT management tool by SolarWinds. So in the White House attack which happened, it's because of the SolarWinds. When numerous high-profile customers install these compromised updates, actors unauthorized or attackers get unauthorized access to their networks, and they'll be able to penetrate into that particular network through this third-party software and gain access. And this could be a large organizations and the government offices. So attackers started gaining such kind of things. Target, which is another example, which happened in 2013, was a massive point of sale network attack, which resulted in first breaching a smaller HVAC vendor connected to the Target systems. Target is a big wholesale organization. And they were able to clearly show how targeting a less protected entity can lead to a compromised major retailer, and theft of millions of credit card numbers happened on that particular day in the Target. So Target is a store, right? It is a retail organization spread across multiple cities in the US. So recognizing such kind of a methods is very, very critical, because once you know this kind of a threat landscape, understand the threat actors which is involved, your ability to put down the defense in depth, your ability to look into the security patches, your ability to build the employee training, and means bringing that kind of a concepts to the students will be improved. So you will be able to develop that strategies to mitigate and reduce the impact of such kind of an attacks as you progressively move forward. This is very, very important when you try to look from the contemporary things. The third, as I progressively move, so today you see that data breaches and are very, very high. And some of the prominent examples which happened in the recent past is from the Equifax and the Marriott. So high-profile data breaches are very much possible because these people are so much easy to attack for the attackers, because their financial health is very high, their legal standings are there, but they will not come out and openly admit that they got attacked. So that is the reason they try to attack. High-profile breaches are possible. So many breaches happened involve the theft of some of the sensitive information, financial or proprietary informations. They target these large organizations with heavy customer data sets so that they'll be able to get huge amount of money, or at least store some of the identities or credit card numbers or trade secrets, which can be really substantial enough for them to trade. So Equifax, what happened is it was one of the largest credit reporting agencies in the United States. Their data got breached, exposing a lot of personal information of their customers of approximately around 147 million consumers. So this included social security numbers, birthdays, and addresses. The sheer volume is such a kind of a huge thing. It increased the risk of identity theft and fraud to a very unprecedented nature. Similarly, the Marriott case was huge. the hotel giant revealed that the hackers had accessed personal details of up to 500 million guests over several years. This information contains all the personal identifier information like names, addresses, passports, and different numbers. And some of the encrypted payment card details are also known. So long-term indication is this particular breaches are very, very high, and it could really damage the trust and reputation of the companies. Hence, all the customers are really looking at enabling that kind of a confidence within their customer community, and also look out for the strategies to restore their brand image. So long-term damage to trust and reputation can really result in, and it need to be safeguarded across the organizations. So once you know that some of the companies' data is breached, so that kind of a suspicion can linger across, and they often you see the customers leaving that organizations to the competition. Once a brand image happens, it will be really, really affecting, and the brand value comes down, it goes to the southward, and it makes more challenging to win new customers or regain that kind of a lost clientele. Similarly, the investors who are investing in that particular organization also will have a lot of problems in trusting the movement, and hence you see that particular organization which has an impact, the stock prices will come down. And it has got a severe implications on the financial and legal repercussions, because once there is a data breach or happens, so one need to come out and safely admit that. That ability to admit is important, and ability to say that I am able to mitigate this way and remediate the situations to this way. That kind of an approach is very, very clearly needed. And they need to be ready for the regulatory fines. They need to be ready for the kind of a lawsuits which they are going to encounter, and also try to restore the lost business opportunities. And then you may end up paying a lot of insurance premiums also. So in nutshell, what I want to communicate is understanding the threat landscape is very, very critical. Understanding the threat vectors is also important. Similarly, when such things happens, it serves as a cautionary tales, emphasizing the importance of the robust cybersecurity measures. And long-term damage could really damage the trust and reputation, and it often exceeds the initial financial losses. So as regulators today now, Europe, USA, and Indian governments have tightened their requirements. Consumers become more vigilant and about their data protection, and there's a lot of financial and legal implications of every breach in the organization is happening. So it's important that we understand this threat landscape when we are trying to teach to our students, and that will really play a very important role. I just want, I don't know, in the interest of the time, but I want you to do this activity offline. So identify a recent cyber incident. It could be for you, it could be for your college, or it could be in your environment. And what was the vulnerability? And how might it have been prevented? This is a very good activity. If you try to do this, probably it will really bring out a lot of understanding. How do I evaluate cyber incident? Understanding the vulnerability is also very important. It could be that your personal mobile phones, credit card information. I'll just tell you on one of the cyber incident which happened with me. Probably you can relate. I was sitting in a hotel with a customer having a lunch, and suddenly there is a series of messages which is popping on my Amex card indicating that 1 rupee, 3 rupees, 5 rupees, 9 rupees. It's kind of a Fibonacci series numbers I was trying to see. I was surprised to know that, and before I reacted to that, I got a call from Amex indicating that we see some set of transactions which are happening in a span of around 2 minutes. We have seen around 18 transactions resulted in 239 rupees. Now my card was compromised, and once my card was compromised, it's an incident, and you see how Amex is detecting it. And this particular transactions are happening from different locations within 2 minutes. And our cybersecurity agent, which was running at the background for the transaction, was able to spot some kind of anomaly, and they really alerted the service desk to report back to the authorized user. Hence, we are calling to check, is this transaction done by you? As soon as I referred, I told I have not done this transaction, they blocked my card. And they told we are reissuing a new card, and none of this particular transaction happened in the last 2 minutes will be charged to you. So creating such kind of a robust framework, creating such kind of a ability to understand the vulnerability, and how do you prevent that vulnerability by blocking the transactions. All these things need to be part of your entire development life cycle. If you do not have such kind of a ability to mitigate, we'll always land up in a trouble. Having said that, let me move into the second capsule of the story, which is about the fundamentals of the software security. Now, when I talk about the fundamentals of the software security, what comes to your mind? When you might have listened to so many stories coming into the different faculties, but what are the common vulnerabilities? Every application is vulnerable, we know. The more digital we are, more vulnerable we know. But some of the common patterns I'm trying to bring it to your attention here. SQL injection, cross-site scripting, insecure authentication. These are some of the common types of web application vulnerabilities which will allow attackers to manipulate data, compromise user session, or gain unauthorized access. Understanding each of these vulnerabilities helps business developers secure their applications against malicious intrusions. Now, if you take SQL injection, it occurs when an attacker is able to insert or inject malicious SQL queries into a web application. I believe some of you are already dealing with it. This typically happens when input fields like search boxes, login forms, or contact forms are not properly validated or sanitized before using it in a database. So say, for instance, a prominent way of SQL injection is 1 = 1, so it will extract everything. Because the condition is true, it will get it. And some of the hard-coded names like username, admin, and password. So they will be able to get interpreted and use that particular condition to get more information and granting the attacker access to that admin account. The consequences are very, very high because successful SQL injection attack can lead to unauthorized data access, which is not expected to be given. Data corruption, stolen credentials, and even complete control over the database where you cannot revert it back, but you should just delete it and come back with the new setup by restoring the information. So what is happening is this is compromising your privacy, data integrity, and overall system security. So you need to prevent. Preventing the SQL injection requires developers should use prepared statements, parameterized queries, input validation, and strict database permissions so that web application firewalls can detect and block suspicious queries. These are the strategies available. One need to apply these particular strategies with very, very judiciously across the development lifecycle. Now, when you take about a cross-site scripting, this occurs when attackers inject malicious scripts. Often, you can talk about the JavaScript into the web pages that are viewed by other users. This typically happens when user-generated content and like comments, message boards, or form inputs, they are displayed to a website without being properly sanitized or escaped. Example, if you're trying to take in the cross-site scripting world, an attacker might post a comment containing a malicious JavaScript snippet on a forum. If the website does not sanitize that input, other users viewing the comment section will unknowingly execute the attacker's script in their browser. So cross-site scripting is very, very prominent in the browser, and it can lead to theft of session cookies. Session management, if it is not effectively done, the session cookies gets compromised, and it will allow the attackers to hijack user accounts easily. It can enable phishing attacks or phishing attempts. Unauthorized actions can be happening, which can really spread the malware to a greater extent. So to prevent cross-site scripting, developers should encode or escape user input before rendering it in our browser. Use content security policies, employ some of the frameworks or libraries that provide built-in XSS protection, which is important. The third thing which we addressed here is about the insecure authentication. Now, authentication and authorizations are very, very critical. So insecure authentication refers to the kind of a weak or flawed methods of verifying a user's identity. How many of you really understand insecure authentications? How many of you pass your password in a very plain text, not in an encrypted manner? So using that kind of a predictable or guessable session tokens, we can really enforce and access that particular information and compromise that. So not using a secure communication protocols will lead to this kind of events. HTTPS is one among the thing which will help in building a secure way of communicating the things. It encrypts the data. So say for an instance, I'm developing a web application. It stores passwords in a plain text in a database. If database is compromised, attackers can immediately use all the passwords of the different user accounts, and they can transmit the data in the login form and credentials over encrypted HTTP, allowing eavesdropper so that they can capture everything. So insecure authentication is a very dangerous. It can lead to unauthorized account access, data breaches, and identity theft. Many people lost their jobs. Many companies had a brand reputation damaged. So generally, you try to prevent it using your secure password hashing algorithms like bcrypt or argon2 or some other methods, which will allow you to securely transmit your passwords across the network. And also at this rest, you store it also in the encrypted manner, so that it becomes very difficult for any kind of intruder or attacker to gain access to it. Second, today you see multi-factor authentication is becoming a very prominent. It's not that only password is able to give you access, password plus OTP. That's a multi-factor authentication, which enforces that secure session handling techniques can be implemented, and so that you will be able to transmit login information over the HTTPS protocol. But these are some of the important areas of the vulnerabilities which you need to take care during the secure coding practices. And building a robust encryption techniques, proper validation techniques, adherence to the industry standards will really bring a lot of change and reduce the risk of the successful attacks and maintain safer and more trustworthy online environments what you try to witness. Now, what to bring your attention to some of the important secure coding. We addressed about it, but how do you implement secure coding practices? Now, we know the prominent vulnerabilities, but just wanted to bring three important practices. There could be many more what you can look at from the different stages of the life cycle. Input validation, encryption, and hashing, and a proper session management are some of the foundational security practices which can help in building and protecting a data integrity, maintain confidentiality, and ensure the authenticity of the user interactions. So these three important entities form the backbone of secure application development and data handling. So let me bring your attention to what is sanitizing the user input validation mean. It involves checking and cleaning data provided by users before processing it in the system. And the major goal for anyone is to see that it is able to meet the certain criteria. Let's take an example, type length or a format you wanted to validate, so that you will be able to interpret that in a right way. So if there is a web form you're creating and it expects a user email address, and proper input validation would confirm that a submitted text is in a valid email format. That is username @example.com, gmail.com, whatever you want to call. If someone gives just a username but not followed by the email ID it is email platform it is associated, it becomes unexpected character, or it can neutralize before it getting used. So consequence of the poor validation is, without having an effective input validations, attacker can exploit vulnerabilities such as SQL injection, and it can also use cross-site scripting. So manipulating the databases, stealing the sensitive information are very much possible if you do not apply the input validation. So developers should use built-in validation functions, apply allow list acceptable characters or formats, so that you will be able to handle all the inputs, do the proper validation before you access the system. It avoids all the injections and harmful way of accessing the information. These are some of the things which you need to be aware of. I believe when you're trying to teach your students as part of the construct, every input need to be validated. Every input to be validated as part of the format under which it need to be used. It's not only about checking whether the data is there or not. Second important thing is the encryption and hashing. These are the methods which are used to protect the confidentiality and integrity of data during storage and transmission. So encryption, when you're trying to look at, it transforms readable data into an unreadable format. Ciphertext, what we call, plain text to ciphertext. Using a key, which could be a public key or a private key. Only someone with the correct key can decrypt and it back into original plain text. So it is used commonly to protect data traveling over the internet, especially for the personal identifier information, login credentials, credit card numbers. And it is also stored in database in an encrypted format so that sensitive information is not compromised. Hashtag is like another way of one-way function that converts data like password into a fixed length string of characters. So in the encryption, you have a keys. In hashing, cannot be reversed. When users enter their password, the system hashes it and it tries to compare it to the stored hash only. If they match, the login is successful. If not, it's unsuccessful. So this way, even attackers can access the database. They only get hashed passwords. They don't know what is a real password, and it is very, very hard and difficult for to reverse engineer. So these techniques like salting, adding some of the random number data are also used. Some of the very, very important algorithms we normally use is a AES, Decrypt, Argon 2. And today, in fact, when we are trying to talk about this, the future is all about quantum. And I would say that some of these algorithms can be broken by the quantum computing. So you need to develop the algorithms which are more quantum proof. NIST is released a lot of encryption algorithms which are quantum proof. Probably we need to start practicing that. The third important secure coding practices is proper session management. I don't know how many of you, I believe everyone is involved in the web application development, but still, when an application maintains a state of a user's interactions, it need to remain the logged in preserving credentials. Say for instance, if you are shopping in Amazon or Flipkart or Shopsy or any kind of a system, how many times you see that your session information is maintained, you close the application, came back after 1 hour, after a couple of days, after 3 days, 1 week. So there is a session lifetime. Some people re-authenticate every 1 day, 24 hours. Some people re-authenticate every time you open the browser applications or the system applications. So it depends upon the kind of a concept they try to use, but it's all about retain user preference actions and avoid multiple page visits. So securing your session ID is very, very important. When the user logs in, a session ID is generated, server creates this, and it should be transmitted every time you are making an interaction with the application server or the database server. So to prevent such kind of unauthorized user. Session expiration need to be associated. Session invalidation need to be associated so that a proper session management can ensure that you are automatically ending the sessions after a period of activity. So immediately invalidating the sessions upon the logout is a good practice. If this is not done, attackers can obtain a valid session ID and can impersonate you after you left. So additional protections in this area can be secure or HTTP only cookie flags can be leveraged. So the session renewal at critical points can be managed. But I don't admit that cookies are a good way of managing the sessions. You need to avoid cookies in the session management. So some of these practices, when you strongly integrate, I believe you will be able to reduce the risk of breaches, improve the trust of the organizations, and maintain the overall security and reliability of the applications to a great level. Now, the third important area which I wanted to touch upon is secure software development lifecycle. Now, you know that right from the requirements to the architecture, design, code, test, monitor, deploy. This is a kind of a life cycle. It continuously happens. Now, how do you identify the risks? How do you identify the threats? Is there a model which is available? Yes, there is a model. I believe you might be heard about SRIT as a model. SRIT stands for STRIDE, spoofing of the data or the identity. T stands for tampering of the data. R stands for repudiation. I stands for information disclosure. D stands for denial of service. E stands for elevation of privileges. The STRIDE model is generally leveraged for doing the threat analysis, understanding the threat landscape analysis, which gives a very good understanding about how threat modeling need to be done. And once you do the threat modeling, you anticipate the threats, you associate it with the risks, vulnerabilities, mitigation plans, so that you will be able to reduce the risk as a long-term objective. So constantly doing the automated code reviews, analysis, and continuous monitoring, and doing a patching of some of the critical components of as part of the robust software development lifecycle, you try to bring this kind of a practices so that potential vulnerabilities can be detected early stage and can be fixed. You can also improve the main code quality. You can also swiftly respond to the emerging threats so that you are strengthening your entire application portfolio, strengthening the security posture of your application. Likewise, you strengthen the portfolio security posture of your enterprise. So if you typically take threat modeling in the design phase, Threat modeling is a very proactive exercise conducted very early in the software development process. So the purpose is to identify potential security risks so that how attackers might exploit a system, so that you implement countermeasures and before it gets developed. So the approach is basically what you try to do is you try to visualize the architecture, the key components, key flows, and integration points, upstream integration, downstream integration points, and you try to educate development teams to uncover where sensitive data is stored and transmitted. If you are able to illustrate the flow, they then consider possible attack vectors so that you can avoid unauthorized access, data manipulation, or injection attacks. Some of this risk, when you identify early stages, you will be able to make informed design decisions, reduces the cost which could result in rework later in the development or in the testing. And it will really build a resilience into your product so that you will be able to withstand any kind of malicious attacks which are coming in. The second important practice as part of the secure software development lifecycle is automated code and code reviews and analysis. Now, automated code analysis. Now, when you really look into the code analysis, there are two important code analysis. One is a static analysis. Second is a dynamic analysis. So both has got a specific purpose. So when you're trying to do the manual code reviews, it's about the expert who's trying to review your code. It's been very, very valuable. Automated tools can help you in building the speed, consistency, and coverage at scale, but manual code reviews gives expertise so that you will be able to leverage. So statics analysis like SonarQube, Fortify, they are very, very good tools which are available to examine your source code without executing and identifying any suspicious pattern, but they are trying to invalidate the inputs, outdated encryption methods, or insecure API calls. All these things it will be able to discover and try to spot it for you. Similarly, in the dynamic analysis tools, it can run the application in a controlled environment, monitoring its behavior for anomalies, memory leaks, or unauthorized data access attempts. That is also possible. So continuously focusing on improving this code scans can help you effectively building the pipeline. So probably you might have heard about DevOps, right? Building a continuous integration, continuous testing, continuous deployment, and continuous monitoring and continuous feedback. This is a DevOps cycle. So across these things today, it's all called as a SecDevOps or PrivSecDevOps, where you're binding privacy and security controls as part of the DevOps lifecycle. So when you do that, you're not only doing the code scans for the functionality, but code scans for the security and the privacy controls also, so that you will be able to take before it gets deployed, you will be able to take the necessary direction and detect the things which needed immediate remediation so that your risk of deployment can be coming down slowly. The third important practice is about the continuous monitoring and patching. So when you're trying to look from the continuous monitoring, it involves a very, very close watch of deployed applications, supporting a lot of infrastructure to detect threats and vulnerabilities as they arise. Some of the monitoring tools you can leverage, like the monitoring tools like Grafana, Dynatrace, App Dynamics. If you're trying to deploy in the cloud, you have the Azure App Insights, CloudWatch. This gives you a lot of information about how your application behavior is happening. It also gives you a good amount of understanding about security teams involved to monitor these particular solutions, logs which is getting created, to spot some of the unusual activities, understand some of the sudden changes in the behavior, understand the unauthorized access attempts, so that you will be able to detect early and respond to the situation or the incident by looking into the threats landscape, so that you can avoid or minimize the damage. Similarly, rapid patching and updates is another method where you can try to identify the vulnerability to immediately try to bring in the required systems to fix those things. And in fact, recently, CrowdStrike, there was a vulnerability which discovered, which was continuously rebooting the Windows machines. So it happened for many organizations. Many of our airport operations were stopped because of that. But as soon as there was a discovery that it's a CrowdStrike patch resulted in that problem, immediately people were able to reapply the patch and restore the operations. People were able to do that. They are able to come back to the operations very fast. People who took time, they need to wait for the leaders to announce what is the way to get rid of that situations. So continuous monitoring and swift patch management can help in maintaining a very, very secure environment for the long term, so that it can ensure that the software remains protected against evolving threats and newly discovered vulnerabilities in the overall context. So every organizations and the student need to be really educated on building them of the strong security foundations, which can allow them to reduce the risk and also create more trustworthy software solutions in the entire landscape. As I say, as part of the software development lifecycle is important, it's very important also to understand DevSecOps. I mentioned about it, but this is part of the pipeline what you need to really look at. So just to touch upon for the people who are not aware of DevSecOps, it is an approach that integrates development, operations, and security into a single continuous process. Traditionally, security checks often occurred very much late in the development lifecycle, causing a lot of delays and the costly fixes. But now DevSecOps, as part of the pipeline, when they are integrating, it shifts securities to the left, embedding into every phase. You are from the initial planning to the coding to deployment and ongoing maintenance. You will be able to treat it as a kind of an ongoing step, you not as a final step. So in the context of the collaboration, you see that development, operations, security teams are working together. In the context of automation, you see that security scans like dynamic and static security scans, code quality checks, compliance validations, all these things can be automated as part of the pipeline. Continuous feedback from the monitoring agents, it can really discover security issues and also provide a lively updates to the development team so that they can apply the fixes and continue to improve the stability of the product. So say for instance, when you're trying to look at a software company, I'm just giving an example how they can integrate. They're creating a new e-commerce website. So traditionally what happens, the developers write code for several months, pass it to the operations team to deploy. This is a waterfall method. They have the security team test at the end, and if the security team finds any serious vulnerability, just before the launch, the project release date gets shifted. It gets delayed. There will be a huge amount of frustration and added costs. But within this DevSecOps, what happens? Security team is involved from the beginning. So whenever a developer checks in the new code, automatic security tools are run immediately so that scanning can provide the vulnerabilities such as SQL injection, weak authentication, any kind of scripts which are getting compromised, integrated security policies, all these things can be looked at so that your new server or new instance or the cloud resource are really following the best practices so that you will be able to apply the security patches or fixes ahead of the time. So if a vulnerability is discovered, the system really alerts the relevant teams so that they can go and fix the things and not rather than getting into the last minute rush. So this ongoing integrated process has dramatically reduced the chance of major security flaws in the entire system, which are resulted in a continuous development operations. Such a thing which you need to be aware of. Building a very secure and reliable software is very, very efficient. But when you try to integrate as part of the pipeline, you can really achieve the objective what you're really intended to look at. So say for instance, this is a small exercise. Again, I don't know whether I have the time to go through each and line, but I would leave this particular content for your reference in the initial stage. This is an exercise where I'm giving you, it's a code base, and I want you to apply some of these best practices into that, where I have purposely introduced some of the inappropriate methods and wanted some of the, so you see password, test DB, this is hard coded, that need to be changed. Session management, that need to be changed. Potential cross-site scripting, how it is. These are the bad coding practices. You need to apply some of the best practices to change these things. So when you really look at it, you need to simple work on this. You can use Node.js, Express.js, whatever the code snippet really you want, and try to fix these things. So your task is to look at input validation. Your task is to look at insecure session management. Your task is to look into the cross-site scripting so that you will be able to fix those things and apply those things. This is the second capsule which I wanted to touch upon. Moving forward, I will try to touch upon the digital forensic essentials also. So today, building the secure software development lifecycle is not sufficient, but you should also have, after deployment, when an incident happens, how do you apply the forensic analysis? Some of these techniques I'm going to touch upon so that you are aware of. So one of the foremost principle of the digital forensic is Locard's exchange principle. So this is originally formulated for physical crime scenes, which is applying to some of the digital investigations. It really brings out two entities interact, there is always an exchange of material or information. In the digital context, when you're trying to look at, this means that any interaction with the computer system, logging into an account, browsing a website, connecting to any particular network, leaves some kind of a footprint. Some information will be available as a trace. So this principle is a foundation in the digital forensic, guiding all the investigation team to look to evidence of a digital footprint where a cyber incident has occurred. So the concept is very, very simple. So whenever a cyber criminal interacts with a network, any particular network or a device or a system, they both leave and take something. For instance, while an attacker may insert a piece of malware, and malware's presence, installation logs or altered file stems will remain. Conversely, you may also look at exfiltrate data so that you are leaving an evidence in logs or transmission records that data was accessed and sent elsewhere. So the principle assures that investigators that even if hackers try to conceal their attacks, some form of digital evidence will provide an understanding that it exists somewhere on that affected host or on the network devices, in system logs or within the metadata. This type of digital evidences are very, very critical in different formats when you're trying to look at, reflecting how the users or attacker behaviors are there and how they are trying to interact with our systems and networks. Some of the digital evidences which as part of the forensic strategy they use is logs, metadata, and the network traces. Logs are critical because it provides a kind of a records of events. I don't know how many of you seen event viewer in your Windows machines. So it provides the system logs, application logs, and all those things. So it occurs with the system. It provides with the application or network. They serve as a kind of a chronological record of activity, and it can include authentication attempts, file access events, or any of the error reports. So if you, for example, if you take a web server is accessing, log might show IP addresses requested particular URLs. So revealing suspicious patterns of unauthorized access attempts. Now that's what the MX example I was referring. It was able to spot some of the unauthorized examples happening because that IP address which is used for transacting is getting changed from one country to another country. Metadata. This is a information that describes the other data. It often provides contextual information about some of the files and communications or transactions. Say, for instance, I've taken a digital photo. How many of you know that your photo which is taken on the mobile phone contains a lot of metadata? It contains a lat long, location, where area of taken, when it was taken, and it can also store information about the author and creation date also. And if your personal information carries an email or metadata, can also include the IP address. So that email's routing path and message timestamps, everything is available for investigators to understand the origin of the email and authenticity of the email. The third important evidence is the network traces. They often refer to kind of records of data traveling across the network. How does it get navigated? Now, Amazon has got a very good service called Amazon X-ray. It provides that compliant end-to-end traceability of the API call. Similarly here, network traces plays a very important role because it could capture network logs, router configuration, firewall alerts, or packet capture files also. So monitoring the network traffic may reveal suspicious information, a lot of inbound connections and from unknown regions, so that you have an opportunity to look at the outbound data transfers or inbound data, abnormal spikes in the traffic, so that you will be able to predict if there is any kind of a potential data breach or exfiltration attempt has been made. So overall, in the Lockhart's concept, it is important that you understand that Lockhart's exchange principles, digital forensic experts know that even the most skilled cyber criminals leave some of the digital clues which can be captured through the actions of the attacker through the logs, metadata, or the network traces, which will help us to bring that evidences to the system by carefully collecting, analyzing, correlating these pieces of information and evidence. The investigators can be able to spot the issue and which is involving, and spot the anomaly, spot the area which is really causing the damage, and they can strengthen that particular area by putting the required security measures. So this is very much needed as part of the forensics. Now, having said that, what is a forensic methodology involved? Now, you know that there is a principle behind it, there is a digital evidence behind it, but is there a methodology associated to it? Yes, there is a methodology associated. You need to really understand. Again, why I'm trying to tell you is not only securely building the practices, but there is a importance for the people also to develop that understanding about the digital forensics, which plays a very important role. So forensic methodology provides a very, very structured approach in investigating the digital incidents. They help in establishing the procedures. They help in setting up the integrity of the evidence. They help in maintaining a reliable record of how it was handled. They help in applying the analysis techniques which can provide accurate conclusions. Some of the key components which are involved in this part is evidence acquisition and preservation, chain of custody, and analysis techniques. These three are very important elements. So when you look into the evidence acquisition and preservation, so how the people acquire? The evidence acquisition is collecting digital data from computers, mobile devices, networks, cloud environments, could be any source. So that during this particular state, it is very, very critical to follow the procedures to prevent any contamination zones or alterations or destruction of the original data. So imaging and copying is one important area where investigators try to often create a bit by bit forensic image of storage devices. Write blockers and live analysis. This is a specialized hardware which is available as part of the software tools, which help in like write blockers prevent accidental changes to the source media. In some cases, investigators may use to collect evidence from live systems, like CCTV feeds and other things also can help in doing a lot of careful planning to avoid any kind of altering volatile data. The documentation, this is a meticulous recording of the date, time, location, method of acquisition is essential. These are some of the important elements in the evidence acquisition and preservation. The second is chain of custody. It is a very detailed document recorded for everyone who handled the evidence, when they handled it, what actions they took. It is critical to maintain that entire process of change in custody from where that particular ownership is getting transferred. So continuous tracking and securing the storage and complying to the legal objectives are very, very critical in this entire journey. The third important thing is analysis techniques, where you see that after acquiring and preserving evidence, forensic experts employ various analysis techniques to uncover hidden, deleted, or encrypted data. So they can understand the context of the digital artifacts. So file system and artifact examination, network traffic analysis, and some of the tools like data carving utilities, memory analysis frameworks really help investigators to identify these patterns. So why these things are important is, as a forensic methodologist, digital forensic experts or professionals can present reliable and verifiable findings, which can help in stand up to scrutiny the courtrooms or boardrooms or anything beyond. So whenever the incident happens, it is important to have that digital forensic methodology to apply to get these things and understand what is the root cause of it. Having said that, what are the tools used in the methodology? How do I collect it? Is there a tools available? Yes, indeed. So if you really go deeply in the digital forensic world, you need to really apply the tools. Autopsy is one of the beautiful digital forensic platform, open source digital forensic platform used to analyze storage media such as hard drives, SSDs, and memory cards, and brings that graphical view to understand, inspect, and extract information from the systems, so that they can recover deleted files also. I was working with one of the provider called Blanco. Blanco is a company which provides a data erasure technologies. Whenever there is a data like laptop or server which gets decommissioned from the systems or networks, you normally say that I'm going to format the data and throw it out in the trash because the life of that particular asset is over. But how do you know that your data is completely erased? Formatting does not say, deleting does not say that you cannot get the data back. In fact, they have shown statistics indicating that people who thrown away just by formatting or decommissioning the data, the invaluable information was sitting. They will be able to recover the data. So it's said that unless you format the disk 7 times, digital forensic experts can retrieve your data just like this. So it's Blanco comes out with data erasure technologies, and they engage with many of the enterprises to erase the data and ensure that that is not recoverable by any tool. If you don't use that, there are multiple tools available in the market. They can use that also. So forensic methodology, coming back to forensic methodology using autopsy, it uses some of the techniques like imaging and verifications, where investigators start by creating a forensic image of the storage device, verifying the integrity, Second, they try to use the data ingestion policy, where autopsy, the image is then loaded into autopsy, which automatically passes this file, categorize the findings, and puts into the documents, emails, and process history. It does an artifact analysis. You can use autopsy's built-in modules to analyze that. And it also uses the reporting features to investigator to document their findings, so that it is clearly giving out from timelines to the results and suspicion artifacts which is associated to it. Now, second important tool is a network analysis tool. Some of you might be using, this is an open source Wireshark available, very, very powerful open source network protocol analyzer. In fact, I would recommend you should teach in your curriculum how to use Wireshark if you are not doing so. It allows investigators to see data packets traversing across the network, identify suspicious communications, and help in reconstructing how an attacker interacted with the system. Generally, when you're trying to troubleshoot any kind of end-to-end response time, Wireshark plays a very important role, how the transmission of your API happened from the client to the database and vice reverse as well. So forensic methodology using the Wireshark helps in doing the traffic capture, where your entire network packets moving from target environment are captured as part of the PCAP files, so that your incident analysis can be analyzed better. It will allow you to do the filtering and analysis, so that you can zoom into a specific IP address or ports which are malicious in nature. It will do a deep packet inspection, so that you can understand what is getting happening within the packet, what is getting transmitted within the packet. So you can see if the data was transmitted as unencrypted, or pinpoint the use of specific payloads which is malicious in nature. And timeline reconstructions. You can also use Wireshark to create a timeline of events showing how an attacker progressed, useful correlating the other data sources. So volatility is the third area where the memory forensics plays a very important role. This volatility is an open source framework focused on analysis of volatile memory, which captures the memory snapshots which can contain critical evidence, running different processes at the background, network connections, encryption keys, some of the chat sessions, and malware artifacts. They use forensic team uses this volatility in the part of memory acquisition, plugin based analysis, and also malware hunting and cross-reference findings. This plays a very important role in troubleshooting the issues. So by using these tools in tandem, forensic investigators can form a cohesive narration of an incident and correlating data from storage, network, and memory. This multi-layered approach ensures a more thorough understanding of what occurred, who was involved, and how to prevent similar breaches in the future. So today, I believe you might be aware that GMR Airports announced Airports Prediction Operation Center, APOC. If not, probably you might be seeing it in the news tomorrow or today evening. So again, Airports Prediction Operating Center, APOC they call, they have the incident management room. When the incident happens, the entire forensic analysis can be happening there. They use these particular tools to achieve the traces and understand what is happening. They use the CCTV feeds, analyze that particular feeds on a continuous basis. Continuous monitoring happens and try to take a prescriptive action through that source. There's one such example which is happening lively now. So thought of sharing that information. Now, this is the third exercise. I want to give it as a handout for you. We're not getting into the details, but say there is a network. What steps do you take to collect and preserve evidences? So there's a network which you have your lab network in your college, and some suspicious network traffic is happening. How do you collect? What do you do? How do you document the initial observations? What you see, why it matters is very important. Similarly, containment. Isolate the affected systems. If you see that is a suspected behavior, how do you isolate? That is a containment. Capture the network traffic so that you understand from the Wireshark TCP dump from where actually this kind of filtration happened. Secure that particular data. Establish chain of custody. Gather the logs and artifacts so that you can analyze it and apply the forensic tools to establish that evidence and start notifying the incident to the right authorities, and increase your continuous monitoring and analysis to see that no more things are happening and correlate with any of the hypothesis information. So summarizing, these are the different steps. So if you typically look at, I just wanted to summarize it for you. When such kind of a scenario simulation you're trying to do, I want you to do this exercise. documenting the observations, isolating or containment, how do you achieve it, capturing the network traffic, securing the collected data, establishing the chain of custody, gathering the system logs, using the forensic tools for the continue cautiously, and notifying the appropriate teams. That communication is very, very critical. Continuous monitoring and analysis, and preparing for the reporting and further investigation. These are some of the steps which will allow you to understand the suspicious network activity happened, and how do you document, how you thoroughly investigate, how you report it back, so that you can establish a defensible strategy with a chain of evidence which can withstand the scrutiny, not because of you, but some of the something loopholes in the system which cause the trouble. So building such kind of a concept is very, very important and critical. So coming last segment of my talk, how do you integrate cybersecurity into your curriculum? Software security we have addressed, digital forensics we looked at, but very important thing is building a security mindset. So whether it is a faculty or a student, it's important constructing a security mindset is very, very critical. So building such kind of a mindset is required, not just about teaching or technical techniques and tools. It's about shaping the way people think and behave by focusing on ethics and responsible disclosure, ensuring and providing that encouragement for people to stay curious and look from the attacker's thinking standpoint, leverage storytelling and gamification techniques, so you can create more engaged and vigilant security culture. So when you look at ethics and responsible disclosures, we need to teach why ethics matters. So when individuals discover vulnerabilities, their moral compass need to determine whether they report this responsibly or exploit them maliciously or ignore and walk out. Reinforcing that ethical standards ensure that the discovered issues are communicated thoroughly through the proper channels, allowing organizations to fix it. Responsible disclosure programs. So rather than creating the panic situations, you are trying to be more responsible by setting clear guidelines where you try to set up some kind of a process, like establishing bug bounty programs. Facebook announces bug bounty programs, Google announces bug bounty, Microsoft, all large organizations announces. So if you're able to discover any kind of a security flaw, we are going to give you a bug bounty, reward you for that. So vulnerability disclosure policies can be thoughtfully handled with a more transparency by building the trust and acknowledge the contribution people are making. So encouraging, second important thing is, as part of the security, building a security mindset is encouraging curiosity and attacker thinking. So security mindset thrives on curiosity and the ability to think like an attacker. And it's very important that you start building such kind of a concepts, so that it will really play a very important role, because you need to come out of your comfort zones. Instead of relying solely on the standard checklist, you need to focus on how could someone misuse this feature. You should ask, what would happen if I input unexpected data? By systematically you consider this particular techniques, you will be able to build programming models much more in a robust manner. Hands-on practice, basically you need to also look at consistently to learn from the mistakes and reinforce the idea of being proactive and curious, so that you will be able to expose the flaws before attackers do. The third important culture we need to bring in is the storytelling and gamification as part of your curriculum. So technical presentations and dry security training can really become dull, but if you bind it with the storytelling and gamification, can make the learning much more interesting, much more immersive, much more memorable and engaging, and use some of the narratives. Why, when people understand the why behind security measures, they will be able to deeply resonate well with you. Sharing a real world breach story, just we talked about NotPetya, WannaCry. Some of the stories can be really stay in the memory lane. Narratives can help people to visualize this, what happened in that, and they'll be able to appreciate the kind of a defense in depth strategies what you are trying to bring in. And also run some of the friendly competitions, hackathons and rewards, so that it can really help them to come into the leaderboard and build that kind of a constant practice and stay motivated in building the secure solutions. And such professional secure building mindset need to happen from the colleges, from the faculty like you, who really drive the innovation in defense strategies, foster trust across the applications, where the security becomes very, very prominent, so that it will ultimately raise the overall security posture of the organizations or the area where they are trying to work. So likewise, I'm trying to say, so when I'm trying to say, I want to also tell you that integrating cybersecurity with the different technology landscape is very critical. Today, you try to talk about artificial intelligence, IoT, data sciences. So relay that kind of a real world projects and understand and appreciate what are the case studies which is really driving the depth. So defense in depth is very important. And as you try to build any kind of a technology stack, across the stack, you need to see that the security postures are addressed, or security defense is established across the layers, and the network level, application level, data level, or web level, irrespective of the stage. You see there is a multidisciplinary approach which need to be embraced continuously to achieve that objective. And you can always have a proper handshake with the guest lectures, just like you're trying to do as part of the faculty development program. But professional certifications like CISSP and certified ethical hacker, some of the security conferences which happens, follow the Black Hat conferences which happens, where many of the cybersecurity players come in to share some of these best practices, can play a very, very important and dominant role. So integrating such kind of a security coding module into your existing courses can really, really help. So I don't want you to say C, C++, Java programs and use cybersecurity as a separate program. Inculcate some of the cybersecurity constructs as part of your development exercises. Every programming model, you take Python, Java, C, C++, any programming model you are trying to teach, integrate security model into that. That makes a big difference how you try to enable security mindset thinking. I'm not only talking that you should introduce this kind of concepts only in the BTech in cybersecurity. BTech in every discipline, cybersecurity can be introduced as part of the security mindset. Very, very critical. And I just want to touch upon one of the prominent SolarWinds attack, and then close this particular talk and open for the questions. So the kind of a supply chain security attack which has been resulted in the SolarWinds was very, very prominent. I just want to bring your attention. I believe some of you might have already seen this SolarWinds attack, what happened and what got compromised. But when you try to deeply understand and the overall story and landscape, you will really appreciate that how people can ignore certain things and how this particular consequences can lead to the effect. So if you try to look at from the supply chain compromise which has resulted in, which happened during the COVID times, it is considered one of the most sophisticated cyber espionage attack which happened, and very, very high skilled threat actors were involved in it. So supply chain compromise was because the third-party systems were there. US-based IT management and monitoring company, SolarWinds, Orient Software suite was used by thousands of organizations across, including the government agencies, US White House, and everyone who was using this. As part of their culture, they were inserting malicious code into the Orient's routine updates. The attackers effectively weaponized this as a channel to breach into the White House and steal the information. So this is one of the prominent attacks which really spreaded very, very fast. How you need not have access to the environment, but through the third-party instances also, third-party trusted sources also, you can inject your malicious code and get access to the information inside without that knowledge. These advanced techniques are very, very powerful, and it can lead to a huge consequences in the organizations. So SolarWinds attack is a kind of one of a very, very strong example which underscored how a single compromised supplier can create a domino effect of global proportions. It highlighted the importance of secure software supply chains, regularly auditing third-party vendors, adopting more rigorous security protocols. This event really changed the entire landscape of thinking that I'm no longer looking only in my enterprise software security, but I need to look into my entire policies, strategies for my entire ecosystem players, where my suppliers, partners are also involved. So ecosystem-driven software security becoming a very important way in shifting the cultural mindset of the people to deal with the situations. So the key takeaways, what I want to tell you is security is an ongoing practice and it is a continuous journey. It is not a afterthought approach, it is a before thought approach. I want you all to think like an attacker and act like a defender, so that you will build a very robust security posture for your enterprises when you're trying to develop the things, or for your students when they're developing the projects. Shift left mindset. So integrating security at early stage will be a really, really good important thing. And building a security mindset with ethical and professional responsibilities are one of the important ways to drive the change. So I encourage you to look at some of the OWASP, Open Web Application Security Projects, SANS, IEEE ACM, and SIG Security Application Center. And some of the books I referred here, Threat Modeling by Adam Shostak, where he brings out a lot of web application hackers' point of view. It describes about that SRIT model for discovering the threats, vulnerabilities, and countermeasures. But it also tries to talk about DREAD model, which helps you in mitigating the things, damaging potential, likewise, reproducibility, likewise. It talks about DREAD, what we call discoverability, affected users. All these things can be also be looked at from that area. These are some of the prominent things which I wanted to touch upon. And I just want to leave your thought with this OWASP top 10 security risks. I'm leaving it for your reading. So some of these particular things are very, very critical. You need to really be aware of. Some of these things need to be handled as part of your application development, as part of the software security lifecycle. With that note, I stop here and request if there is any particular questions. Thank you.
Thank you, sir. Thank you, sir, for such a wonderful session, sir. Balaprasad, sir. I request any participants, if you have any queries or interact with our expert, please unmute yourself. You are free to ask, sir.
Yes, ma'am.
Yes,
Ma'am,
sir.
can I?
Yes,
Yeah.
sir. Krishna, sir.
Thank you, sir, for providing all this information. So there is a few things that I wanted to ask you. You talked about authentication, and over here also, as we can see this, the seventh point, which talks about identification and authentication failure. I wanted to understand if, when it comes to machine, human to machine, it makes sense. Like you can still make some mistake, and probably you end up giving out your credentials. But when it comes to IoT, where we are talking about machine to machine communication, and one machine needs to, kind of identify the other machine whether it is authorized or not. How do we go about it? Because soon we're going to see 4.0, which we are already talking about. So in that scenario, then what's the importance of authentication as such? Like,
so you think that if it is human authentication, it is possible, but when it is a machine to machine authentication, how are you going to validate? That is what your question is?
Yes, sir. Because now, say, suppose one small example, maybe it's a random one, but when we talk about you have fast tags and you go to the toll and there are readers which are supposed to read the fast tag. Now, if I say, then how do you know that this is the genuine reader which the fast tag needs to provide the data with, or probably any random person who's able to come up with their own reader is able to fetch that data and probably use it. That's the scenario, kind of.
See, basically, when you're trying to deal with the machine-to-machine authentication, so it's more about the endpoints which are involved in the communication, and you need to see that endpoint reliability is very high. And how do you try to deal with the endpoint reliability? Is you need to look into the mutual authentication process. For example, using TLS with the mutual authentication can ensure that each machine provides its own digital certificate signed by a trusted certificate authority. So it can confirm that machine certificate before a communication begins. That's one way of doing it. The second way of doing it is when you are trying to deal with the MTM communication is, can you look at the possible secure key pairs or digital certificates to establish trust? Trust is important between machine to machine. So proper key management techniques are important so that you will be able to prevent attackers from forging the identities. The third category when you try to look at is reliable certificate authorities, or PKI is what we call, right? Public key infrastructure issues, which provides the trusted certificates. And how do you use that trusted certificates for each machine's identity plays very important role. So machine is identified by the certified PKI and you need to continuously renew that, revoke it if it is not part of the system. In the context of your vehicle, when it is moving through that particular, the fast track, what you are trying to talk about.
Yeah.
So fast track is one particular machine, and it's trying to scan your fast track barcode code, and it's just getting that. But there is another machine which is trying to validate it. But both need to be communicated. So your fast track is sending, whether it is a valid or not, it tries to validate that particular certificate of the source from where the request is coming. If it is source is requesting is certified, then it will validate and give that. If it is not certified, there is an anomaly detection which can be spotted immediately. So by regular auditing and monitoring ongoing checks, you can understand which are the different fast track machines which are connecting my source to validate this particular things, so that you will be able to spot the suspicion activity and spot that anomalies and try to make the required action. So there is a lot of trust in the by maintaining a very high level trust in the M2M environment, you can really develop these strategies.
Okay. So continuing, sorry, just one last thing. So when we talked about the keys part, where we talk about the keys, you need to have a good key pair logic. So in IoT, we've seen that okay, they are not able to process it, so they have low computational power. So the key size is also reduced. So how do you manage this where you're reducing the key size, and so it's very easy to someone to kind of brute force it and get the information out of it, and also maintain it so that it's not that easy to break the keys and all, because the key that you're creating for an IoT device may not be done on a cloud. It will be done on the device level itself, which can be an edge device, which can be any other device also. So then how do you maintain this kind of trade-off between the key size and the computation, since we don't have it? Because that's...
So this is a very interesting question. Basically, you're trying to talk about the edge security, if I'm understanding correctly.
Right? Yes,
sir. Okay. So when you're trying to look into the edge security, the edge devices generally have a very low memory footprint, no doubt about it. So the length and complexity, basically in that context, now you normally use a strong and cryptographic keys, because length and complexity plays a very important role in making the decisions. So generating the long and complex keys are harder to guess. So you try to use RSA 2048 or ACC 256 to use that. And second is a random key generation is another simple way of using that. Your keys are very much unpredictable. So this is one particular technique which IoT devices utilize. Beyond that, you should also look at the secure key storages. Now, the vaults, what you are trying to say, or the trusted execution environments under which you're trying to look at, or even the HSMs, the hardware security modules which are there, where you're trying to store your keys in the hardware-based security components, can protect against extraction and tampering. That is one of the way of looking at it. The third method, which I strongly see in the field in the multi-edge deployments, is regular key rotations. They don't rotate keys in a periodic manner, so that attacker, even if it obtains any particular key, it can become obsolete very, very soon. So automated key management and short key lifespans can play a very important role in distributing the keys, and revoking and renewal of these keys can make your regular key rotation playing a very important role. Fourth important thing in the edge area where we normally use is rate limiting and lockout policies. Means if a particular attempt is made on a particular key and there are 3 or 4 failures happening, you lock the account. You disconnect that particular device. So such kind of a thing can play an important role. And again, in the multi-edge area, you see multi-factor authentication, device identity plays a very important role. It's like device fingerprinting, certificates, all comes into the action. So even though you put on all these things, continuous monitoring and anomaly detection plays. You need to get understanding about intrusion detection system should be there in the M2M environment, very, very rare. And whatever the intrusion detections are happening, you need to spot that and provide real-time alerts. And in the M2M environment, you see this stronger protocols and frameworks are heavily utilized. The PKI framework or TLS, DTLS communication plays a very, very important role. These are some of the strategies which are getting used, and you can significantly reduce the potential likelihood of the brute force attacks. by safeguarding the devices and network. Hope that gives some kind of a directional view.
Yes, sir. That's a lot of information. Thank you. Thank you for that. Thank you, sir.
Yeah.
Yes, Krishna sir, is it your question is answered?
Yes, ma'am. Yes, ma'am.
Yes, sir. Thank you,
Definitely.
sir.
Yeah.
Sir,
Thank you, ma'am.
yes, sir. Sir Balaprasad, sir, we have a few questions in chat boxes, sir. I will read out few of them, sir.
Sure.
Yes, sir. The first one is, so there are so many courses from, so the question is from, so there are many courses in cyber security from various universities for MTech and practical knowledge. So is it mandatory to take this? So this is the question, sir. What would you answer,
Courses are
sir?
many, but I would say that
What
the
would you
foundation
suggest,
is
sir?
important. My suggestion is building the secure foundation learning is important. It's not about completing the course, but how good the foundation constructs. So if you can create that foundation layer construct, it will be very high. But what I feel is strongly going on the field and doing the job. Associate your team, associate your students to simulate that scenarios, apply the tools, and practice those techniques. Not the course completion, but doing the practical problems will really help you to enrich your understanding on the ground level. So I really not a great fan of running through every course, but running through every concept in the field and getting a hands-on experience can make your life much more easier. Focus on that, and that's where your industry collaboration can fetch you that real-time scenarios or simulations where you can apply these tools, frameworks in consistently and see that. Now, very good question which was asked by Krishna. Create that edge scenario where automated EV functions are happening, where the machine-to-machine communication is happening. And how do I do the key rotation? How do I do the M2N? So such scenarios are invaluable. And if you can do that, all these basic constructs are known. That's the reason I was trying to say, think like an attacker, act like a defender. So that is only possible when you do simulations. Focus on simulations rather than multiple courses. As part of the simulation, you hook to the course, get the knowledge, apply it. Okay.
Thank you very much, sir. Sir, we have one more
Sir.
question in the chat box, sir.
Yes, sir.
Which static code analysis tool is mostly used for secure coding practices, sir?
Sonar Cube.
Sir?
Sonar Cube.
Okay. Sir. Okay.
Okay, sir. Thank you.
So, participant? Yes, sir. These are the questions, sir, we have.
Thank you. Regarding the PPT, I'll share it with your Shashikala madam and she'll broadcast that to you.
Sir, thank you very much, Balprasad sir. We extend our
Thank
sincere
you.
thanks on behalf of SRIT for your valuable time, effort, and contribution to this faculty development program, sir. We look forward.
Thank you.
We look forward to the opportunity to collaborate with you again in the future, sir. Thank you very much,
Thank
sir.
you. Thank you.
I
Thank you.
request the
All the best.
participants to take one photograph, sir. 1 minute, sir. Participants, please turn on your videos to take the photograph. Thank you very much, sir.
Thank you. Thank you, ma'am. Thank you. All the best wishes for the rest of the program.
Thank you, sir. Now, I request the sir to leave the session, sir. Thank you, participants, for your patience and active listening to the classes. So, we close the session now. Tomorrow again, we will meet. Thank you very much. We shared the feedback link in the group. You can fill that form.
Thank you, madam.
Thank you, madam.
Back form kada.
Thank you, madam.
Thank you, ma'am.
Madam, please share materials, madam, last 3 sessions.
Sir, we collect all the materials. We share it with you, sir. Tomorrow I will share
Okay,
some
okay.
of them, sir.
Okay,
Whatever
thank you.
received, I will share it to you, sir.
Okay,
Okay.
okay, madam. Please send link, feedback link, madam.
Also share the
Okay.
recordings.
Okay, ma'am. We are in that process. We will definitely share it in the group, ma'am.
Rishi madam, shall we close the session? Shall we end the meeting?
Madam, stop the recording, ma'am.
Madam, still not shared feedback link, madam. Feedback link is not shared still, madam, in WhatsApp group.
Okay, sir, we will send a couple of minutes.
Okay, madam. Thank you.